Hey everybody, today I'm super excited to share with you a brand new full stack web application project. We're going to be building a bookmark manager from scratch using Angular on the front end and Nest.js and GraphQL on the back end. We're also going to be making use of a tool called Apollo Angular Code Generator, which is going to generate Angular services for us automatically that includes all of our data fetching logic. So we don't have to write any code, we're just going to have to provide our GraphQL endpoint and it will take care of the rest. Super cool stuff. So let's go ahead and jump right in. I'll see you there. Okay, so we're going to start off with setting up our Angular front end and adding Angular material. So I have the Angular CLI already set up on my machine. If you don't have this, I will include a link in the description so you can get the CLI as well. Once we have the Angular CLI, we can simply run ng new and then the name of the application. In this case, we'll call it Booker. And then this will be run in the directory where you want to create this front-end application. So it's going to ask us if we want to add routing. We will say yes. Then we see which style sheet format we would like to use. We're going to go with SCSS here. And then we can see that Angular is bootstrapping our application and installing the packages with npm. So go ahead and let this finish. So once that's installed, we can cd into it and then open up this directory in our code editor. I'm using VS Code. So once we open this up, we should see our Angular app all bootstrapped here. So we're all good to go. And now we can go ahead and add Angular material. So to add Angular material, we can go ahead and use the Angular CLI. So we can use ng add Angular material. This will add Angular material for us. Then we can go ahead and choose which theme we'd like. I'm going to go ahead and choose pink, blue, gray, but feel free to choose whichever one you'd like. And then go ahead and hit yes for the Angular typography styles. And then we don't need to set up browser animations. So we can go ahead and just let Angular finish setting everything up. And then we can go ahead and run ng serve to start our application. And once this is finished compiling, we can go ahead and open up the browser at localhost 4200. So at localhost 4200, you should see the default Angular starter page here. And so if you're able to see this, that means we've set up everything correctly and we can start building out our application. Okay, so we're going to go ahead and open up our app folder here, and then in the app component.html, we can actually go ahead and just remove all of this boilerplate HTML. We're not going to need any of it. So let's just move all of the placeholder HTML, and then we'll keep the router outlet here so that we can still implement routing in our application. So next, we're going to go ahead and open up our index.html. And if you notice, Angular material is automatically added the Roboto fonts for us and the material icons. So we're also going to go ahead and add another class to our body here. You can see it's added the matte typography class in order to apply the material typography styles. I'm also going to add matte app background, which will go ahead and apply the background based on the theme that we've chosen. So after you do that and you refresh your browser, you should see our application with a darker background. Okay, so let's go ahead and set up a header first for our web application. So I'm going to open up a new terminal in VS Code, and then we can run ng, which will be shorthand for generate, and we'll add module, and we'll add header. So this will go ahead and create a header folder for us in our app directory with a header.module. And then we can go ahead and run ng generate component header, which will automatically generate all the files we need, as well as update the header.module here. So now that we have our header component, we can go ahead and open up the HTML. So for our header, we're going to take advantage of the material theme toolbar, which is called matte toolbar here. And this will wrap our entire header. And we'll go ahead and actually give this a class of header as well, so we can apply some styling to it. Firstly, I'm going to go ahead and add a link here, and we're not going to have an href, but instead we're going to have a router link, which is how Angular router handles links, so that when a user clicks on this link, their whole browser isn't refreshed, but we just navigate to the correct page without reloading the browser. So in this case, this router link will go to the home page, the root of our app, and it will simply have the name of the application. So So this will be our logo here. We can give it a name, h1 of Booker. Okay, so then let's go back into our header.component CSS, give some styling here. So in our header, the class that we just gave, I'm going to set the display here to flex, and justify content, I'm going to do space between, and this is because we are going to add some menu items later on. And then for our h1, where we have our logo, I'm going to set the font size here. I'm going to give it to XX large. So now we need to go into the header module and actually import the material toolbar that we're using. We're going to import the mat toolbar module, as well as the router module, which we use in order to route in our HTML. And we can import the mat toolbar module from Angular material toolbar like so. So next we're going to go ahead and actually export this header component so that we can use it in our app component, because we want this header to be displayed no matter where we are in the application. So in order to do that, we can open up our app component.html, and above the router outlet, we can include the app header here. Now we'll also have to include it in the app module as an import. So we'll add the header module here as an import. So if we take a look at our browser now, we should see our toolbar here with the name of our website, Booker. But if we look at the link, it looks kind of weird. It doesn't match kind of the theme that we have set up. So let's go ahead and take a look at that. Okay, so let's go ahead and apply some global styling in our application. So if we open up our styles.scss, this style sheet applies to our entire application. So in order to get a handle to the current theme we have, which we want in order to apply some global styling, we're going to import at the top here, we're going to add an import. So we're going to import node modules Angular material theming. So now that we have access to that, we can also include mat core, which will include non-theme styles for our application. Now we want to define two variables, the primary color and accent color. So in this case, I know I'm using mat indigo and mat pink. So I'm going to define these two variables using mat palette function here. So if you're using a different theme, you can simply use the correct primary and accent here, and then have these variables defined so that you can use them in your global style sheet. So now we can specify that all of our links, we want to have a matte color. We can use the matte color function and use the accent color. I'm also going to set the cursor to pointer, and let's add a text decoration to underline here. So additionally, we could also create a separate file called variables.scss and just export these primary and accent variables if you needed them in additional style sheets. However, we're only going to be using them here for this project. So now if we look at our browser, we should see the title of our app, and it looks much nicer with our accent color applied. Okay, so now we can actually go ahead and start setting up our login form, our login and sign up form for our application. So let's go ahead and use the CLI again. We'll use ng generate module, and I'm going to make this in the auth folder. So in the auth folder, we'll have a sign up folder. So this will create the sign up folder and then the sign up module. We can also go ahead and create the component. So let's go ahead and do the same for our login. So I'll go ahead and generate auth login. So make sure we generate the module first here, ng generate module auth login. And then we can also generate the component. Okay, and lastly, this login component and signup component are going to share a lot of logic between them and markup as well. So I want to have another component that is living above both of these components that can host all of that shared logic and markup. So in order to do that, we'll generate one final module here, and this will just be the auth module itself. We'll generate the auth module and then the auth component, which is going to hold all of that shared logic and markup between the signup and login components, so we don't have to duplicate it. Okay, so in order to actually use the login and signup component, let's open up our app routing module here, where we define the routes for our application. Now we have two new routes that we want to add, that we just added. So let's add one here. So the first will have a path of /login, And of course, we know that this component will be the login component. And then additionally, we have another one here, so we can add another object. This path will be signup, and the component will be the signup component. Now, importantly, because we're using these components on the app level here, we want to actually import the login and signup modules in our app module. So as a good rule of thumb, any components that you're using in your app routing module, you'd want to import that associated module in your app module. So let's go ahead and import the login module here, as well as the signup module. So now if we go back to our browser and we navigate to /login, we can see we have the text login works, and we should see the same thing for signup works. So let's go ahead and start actually building these components out. So like I said before, we're going to host all of our shared logic between the two in our auth component so that we don't have to duplicate it. So let's go ahead and start with wrapping everything in our auth component here with a div with class container so we can apply some styling. So first of all, I want to give an h1 here where we give the name of the app, so that's the first thing the user sees. So we'll have h1 booker. And now we're going to use the material forms in order to build out a nice looking form that reacts really well to user input. So first of all, we're going to wrap everything in mat form fields for each field we have. So in this case, we're going to have two fields for both components, an email and password field. So firstly, I'm going to give this an appearance property, and I'm going to give it appearance of outline, which just changes the styling of the form field. Then we can give it a mat label. So in this case, this is the email field. And then we have the actual field itself. So input type text, we can actually change this to email. And then we need to give it the mat input attribute, as well as the form control here, where we specify which field in our component that we want to bind this property to. So in this case, we will just simply call it email, and then we'll set this up in the component shortly. Lastly, we can specify the required attribute here. So now we can go ahead and actually add a mat icon as well to give this a nice icon. We'll go ahead and add mat suffix here so that it's placed at the end of the form. And then we will use the email icon here. And lastly, we're going to have a mat error here that will specify the error message if something is wrong with the input field. So in this case, we'll add an ngIf, which specifies if the email dot invalid. So if the email is invalid, that's when we will show this mat error, and then we will use our method that we will define shortly called get email error message in order to get the correct error message for this property. So now we're going to do the same thing except for the password. So we can just copy this first section here, just change the mat label now to be password. And the type here should be type password to provide some hidden protection. In the form control, we'll of course change this to password. And then for the icon, we can use the lock here. Lastly, we'll change the mat error to be password invalid. And we can change our function here to get password error message. So lastly, we're going to go ahead and add a button in order to allow the user to submit the form. So this button will have a selector here of mat raised, just to give it a bit more of a raised look. Mat raised button. And then we can specify the color. So we want it to be the primary color of the current theme. And then lastly, we'll add a click listener to the button, which will execute the onSubmit function in our component. So we're also going to want to add a submit label property here. And this is because the text here for our button will be dynamic, passed in based on whether it's the login or sign up component. So we want to allow that to be dynamic here. So let's head into our auth.component and actually start fleshing out some of the logic in here. So firstly, we're going to add the email property, which is going to be of new form control from Angular forms. So now we can specify a default value for the form state. We want it to just be empty, and then we can pass in some validators here. So let's pass in validators.required and make sure we import validators from Angular Forms as well. And we can also add validators.email to ensure that this is a valid email. Next, we will do the same for the password property. It's going to be form control, no default value, and we can just give it type of validators required. So now we have an email and password. Let's go ahead and implement the error functions here. So get email error message. We're going to check to see if this .email.has error required, because that's the first validator we have. We're going to return an error message saying you must enter a value. Otherwise, we're going to return this .email.has error. Then we'll say not a valid email, meaning that the email validator was not correct. If not, then we can just return an empty string. So let's go ahead and do the same thing for the password. We can just copy this function over. Of course, we'll change this to get password error message. And we can remove the bottom line here and actually just return an empty string because we only have one validator, and that is this .password has error required. So if the password's not supplied, we'll get an error message. Finally, let's go ahead and implement our onSubmit function. So when the user submits the form, what we want to do is we want to actually alert the component that is hosting this logic so that that component can handle its submit logic individually, because the submit logic for sign up and login will be different. So in order to do this, we're going to actually add an output here. So we'll use the output decorator from Angular and call it onSubmit event. So this will be a new event emitter that our components can actually listen to and respond to. So for now, we'll have any as our property here. And so now on onSubmit, we are going to call this .onSubmit event.emit, and then we can actually emit the event. So of course, we'll need to pass the email, which will be this .email.value. And for password, we'll emit this .password.value. Now lastly, make sure you correctly import event emitter from Angular core and not anywhere else like my VS Code likes to do. So finally, we're going to add the input decorator here as well so that we can allow that submit label to be supplied by each component, which is of course a type string. Now, if you get an error here for this input decorator saying it has no initializer and is definitely not assigned in the constructor, this is just a product of our TS config setup. And we can actually disable this if we go ahead and open up our TS config and actually just add a property at the end here in our compiler options, set strict property initialization to false. And so now that error message should go away. And we have everything we need for our auth component to work properly. So one last thing, don't forget in our auth module, we're going to have to go ahead and actually import the material mat form field module. We'll have the mat input module, which we're using. We need the mat icon module, the mat button module, and also the reactive form modules from Angular that we are using. And so I'm going to go ahead and add all these imports up above here that you can feel free to copy over. And lastly, we're going to want to export this auth component so that our login and sign up forms can take advantage of it. Now we can actually create our sign up form. So in our auth directory in sign up, in our sign up component, let's go ahead and include the auth component that we just created. So in auth component, we can see that selector here is app auth. So we just need to include the app auth component, and then we need to bind to the onSubmit event that the auth component exposes. So we're going to have our sign up function, and then we're going to pass the event, which in our case is the email and password in an object. And then we're going to need to provide the submit label, which of course will just be sign up. So make sure you include this in single quotes here because it's a string literal, and we'll have sign up. So this is all we have to do to include our signup form. Now let's go into the signup module. In here, we're just going to want to make sure that we actually import the auth module. Now let's go back into our signup component. We're going to need to add this signup function. And we know this is going to be an object with an email and password. And for now, we're just going to make it of type any. And we're not going to actually do anything with the email and password, but we can just log it out to make sure that we're receiving it here. So if you remember, we added our signup component to our app routing module already. So if we open up a browser at localhost 4200 and we navigate to /signup, we should see our signup form here. Granted, it is a little ugly right now, but if we enter our email and password and click sign up, we should see it get logged here. So let's quickly go ahead and apply some styling to our auth component so that our form looks a little nicer. So we're going to add these styles to our auth component so they apply to login and sign up. And if you remember, we have a container class that we're wrapping everything in. I want to display flex here, and then let's justify it center. We're also going to align item center. Flex direction will be column, and then I'm going to give it a height of 100 view height so that it's going to be in the middle of the screen. And then lastly, I'm just going to give a little bit of margin to our button here. So I'll put margin top, and we'll use 1 rem relative units here so that this will be a scalable unit. So now let's go back to our browser. We can see a much nicer looking sign up form here, and we can quickly test out our validation here. So if we are to remove our email, you can see that we're prompted that we must enter a value, and you can see that it has to be a valid email. And same thing for our password here. So as soon as we enter a valid email and password, our validation goes away and we're able to sign up. So now let's set up our login form, and this will be very similar and very easy to do because we have our shared auth component. So like we did before, we'll include our app auth component. We will bind to our on submit event, and this will be a login function now, where we're still passing the event with the email and password. And then we'll have the submit label here, which in this case will now be login instead of sign up. So now we just need to go into our login module and make sure we import the auth module. And then lastly, let's go into our login component, and we'll have our login function here. We know we're getting the email and password. And for now, this will be of type any. And in here, all we're going to do temporarily is just log it out to make sure that everything is wired up properly. So now back in the browser, if we navigate to /login, we should see a login button now. And if we enter our credentials, we can see in the logs here our email and password. Okay, so now that we've set up the bare minimum for our UI, we are ready to initialize our backend Nest.js application so that we can actually create accounts and authenticate the user. So in whichever directory you'd like to create your backend project, you're just going to run nest new, and then you can give it whatever name you'd like. I'm going to call it Booker Backend. So you can use whichever package manager you'd like. I'm going to use pnpm, which is actually the fastest package manager out right now. And we're going to go ahead and let Nest finish initializing the project. So once we're initialized, we can cd into the backend. And I'm going to run pnpm start dev. We're just going to start up our server. And now in VS Code, I'm going to go ahead and file and then add folder to workspace. And then I'm going to select the backend folder. So now that we have a workspace with the front end and the back end in the same project, and then you can feel free to save this workspace. But the first thing we're going to have to do is install some dependencies in our backend so that we can create our GraphQL resolvers. So we're going to go ahead and npm or use yarn, whatever manager you're using, pnpm in my case, to install Nest.js GraphQL, Apollo GraphQL, and Apollo Server Express. So after we install these dependencies, we can actually use Nest to generate our module and resolvers. So let's use Nest generate, and we'll use module. And so our first module will be users, because we're going to have to actually be able to create new users. So let's go ahead and generate a resolver for users as well. And lastly, we will generate a service for our users. So we'll have a user service. So now that we have our users folder here with all of our initial files created, let's open up our app.module so we can actually initialize our GraphQL server. So the first import we're going to add here is the GraphQL module, and we'll call for_root on it. And I'm going to provide auto schema file set to true, which just means that our GraphQL schema file will be automatically generated using the code first approach, and this file will be living in memory so we don't have to deal with it ourselves. Now we're also going to have to provide a driver property here. In our case, we're going to be using the Apollo driver, and we actually import this from Nest.js Apollo, and we can also provide some type inference here by providing Apollo driver config here. So we have a GraphQL module for_root with our auto schema file, and then we have the driver here, which is the server adapters. In our case is Apollo. So now we're ready to start working with GraphQL. If you have any errors right now, don't worry. That's because we don't have any models set up for our GraphQL schema. So let's go ahead and fix that. In our users directory, we can create a new folder here called models. And we'll go ahead and create our first object type for GraphQL. So we'll create a user.model.ts. Okay, and we're going to decorate this with object type, which marks a class as a GraphQL type. And then we can export a class called user here. And now we can provide the properties for a given user. Now, I of course know that all of my models in our application are actually all going to have an ID property, and that's because we're going to be persisting our objects using MongoDB, which automatically uses the _ID field for its entities. So instead of duplicating that property on all of our models, I'm actually going to go ahead and create a new folder called common, and in this common folder I'm going to create a new abstract model. And you can think of this as just a default object type that includes all of the properties that every single object type would have. And this is so we don't have to duplicate all of this. So in our abstract model, we'll have our first field. And this field, I can give it just a read-only property. I know we're never going to be changing these properties. And it's going to be an ID of type string. So MongoDB will automatically populate this for us. And now in our user model, we can extend this additional abstract model. And so this allows us to keep our code a bit more dry. And so now we have a different field for our user. Our user is going to have an ID, and they're going to have an email. Now a user is also going to have a password, but we do not want to expose this to our GraphQL server. We don't want allow out the outside world to query passwords because that would be insecure. So this is what we're going to keep the user as for now. So now let's go back into our users resolver, and we can actually provide this user model here now into our resolver decorator to specify some type inference. Okay, and now let's go ahead and firstly inject the user service. The first thing we're going to create is a mutation so that we can actually create a user. So we'll import mutation from Nest.js GraphQL, and then we're going to return a user from this mutation. This will be async. We'll call it create user. And now we need to specify the arguments that we're going to receive when we receive this call to create the user. So this is going to be called create user data that we're receiving. Create user data. And now we need to actually specify this type. So instead of our users directory, I'll create a new folder called DTO, which stands for data transfer object. I'll create a new folder for input because this is going to be an input type, and this will be called create user input.dto. So we can decorate this class with input type, and we can export it. So export class create user input. And like before, we have our fields here that are decorated so that Nest.js knows to add it to our schema, our GraphQL schema. We know we're going to get an email and a password from the client. So we're getting an email and password from the client, but we need to validate all input into our system. So Nest.js makes that very easy to do. Let's just open up our terminal and we can install a couple packages here. We'll install class validator and class transformer. So after we've installed these, we can actually open up our main.ts file. In our bootstrap method, we are going to add a global pipe. So call app.useGlobalPipe and add a validation pipe, which comes from Nest.js common. So now that when a request comes into our system, it's automatically going to be run through this validation pipe, which will look at any class validator decorators we put on our classes and enforce them. So for example, this email property, we can actually verify that this is an email. So to do that, we'll import is email from class validator. So now this is going to verify that this property is actually a string and it's an email. And for our password, we can simply say that we don't want it to be empty. And of course, it has to be a valid string. So now let's go back into our users resolver and we can actually specify a type here, create user input. And now we are going to return this.userService.createUser, which we don't have yet, but we know we're going to be offloading this create user data into that method. So let's open up our user service here and we can add a new async create user method that of course we know takes the create user data, which is of type create user input. Okay, so now we're going to provide our first query for our resolver here. So we're going to use the query decorator and make sure we actually import this from Nest.js GraphQL and not Nest.js common. Inside of here, we're going to specify the type of model we're returning. So in this case is a user. Now I'm going to specify the name of this query to just be user because I want the name of the function to be getUser. And by default, GraphQL will use the name of the function to name the actual query. But in this case, we want the query to be user. So now we can specify some args here for when we want to get a user. So we'll call these getUser args. And this will be of type getUserArgs. So we're going to actually open up our DTO folder and create a new directory in here called args. And we'll create our getUserArgs.dto. And as we did with the input type, we're going to decorate this with args type. So Nest.js can transform this into something that GraphQL understands. And then we can specify the fields that we are going to allow for arguments here. So in this case, we're just going to have the ID property of type string to query a user. So we'll know this it's a string here, and of course it's not empty. So we're going to apply that same validation using class validator. And then let's go back into the resolver now. We can actually bring in the get user args, and we'll return this .userService.getUser, which we will implement and then pass in the get user args. So let's open up our user service and let's also add our async get user method where we have the get user args here, and if this is type get user args. So of course there's going to be some different packages we need to install to use MongoDB, which is our database of choice for this project. So in your package manager, install Nest.js /mongoose, and then mongoose itself. We're also going to go ahead and install Nest.js config, and this is because this will allow us to use the config service and provide environment variables through an environment file, so we don't have to hard code strings and other environment information. So after this is done and you've installed these packages, open up your app.module and let's, in our imports, import the config module from Nest.js config. And we're going to call for root here. And let's specify that this is a global module so that we don't need to redeclare it in every different module that we want access to. Okay, and so now that we actually have access to this config module, we can actually make use of a .m file. So in our backend, in our root directory, let's create a .m. So make sure we actually create this in the backend. We want to create a .m file, which of course doesn't get checked in to Git. So this will not be included in Git. So we can actually add this to our git ignore. You never want to include a .m file. And then in this case, we can put all of our secrets or runtime information here. So in our case, we will include the port number that we want the application to run on, because this could be a dynamic value that would change depending on the runtime. And then we'll also go ahead and include the MongoDB URI that we want this project to run on. So in this case, for local development, we know it's going to be MongoDB : /localhost / and then you can specify the name of the database you want to use. So in my case, it'll just be called Booker. So now let's go ahead and actually use this configuration file, this .m file. If we open up our source folder in our main.ts, before we're actually hard coding the port that we want to listen on here. But that's not best practice. We want to actually get this from the config service. So let's get the config service here. We'll call app.get and then pass in the config service. And then we'll get access to the port here. So port's going to be equal to config service.get, pass in, it's a type string we know, and then the name from the M file. So of course this is port. So we can go ahead and let's go replace app.listen with this dynamic port, which is going to be injected from this environment variable. So now that we have this environment configuration set up, let's actually install one more package to give us a little bit more safety here, called Joy. So I'm going to pnpm install Joy. And Joy is a built-in validation package. We're going to actually validate that we have these environment variables when our application starts up, because it's best practice that we don't want to start our application if we're missing very important environment information. So we can add a validation schema to the config module here. Now this will be joy.object, and then we can specify the environment variables that we need to have, or else the application won't start. So in this case, we know we need a port, so we can call joy.number.required. And we'll do the same thing for the MongoDB URI, joy.string.required. So what this will do is if the application starts up and we don't have the port or the MongoDB URI, we will explicitly be told that by Nest, and it will be a good check for our application startup. Okay, and we actually want to change the import here from Joy to import star as Joy from Joy. Okay, so now we're actually ready to set up our database connection. Let's have Nest create a new database module for us. So we'll call Nest.js module database. So this will have Nest create a new database folder for us, and we can open up this database module. And in our imports section here, create an import section, we are going to initialize Mongoose. So we'll call Mongoose module for root, and we want to call for root async so that we can provide an asynchronous configuration here. So in this case, it's going to be use factory, and we want to actually inject the config service so that we can use that environment variable that we set up. So we're going to return an object here where we specify the URI. And like we did with the port, we're going to call config service.get, say it's a string, and we know it's going to be the MongoDB URI here. Now also don't forget, we actually need to manually inject the config service here so we have access to it. Okay, so now we're actually ready to use this database connection. So the first thing that we have to do is actually define our schema that we want to work with. So just like we did with the user model, in our models folder, we'll create a user.schema now. So we have a user schema, and this will be decorated with the schema decorator. Now I'm also going to specify the version key false here. I don't want Mongo to automatically add version properties to my documents. I'm not going to deal with versioning. So then we're going to export a class called user document. And now we're going to specify the properties on this document. Now, just like we did for the user model, I'm going to have an abstract schema that I know is shared amongst all of my different schemas. So in our database folder, let's go ahead and create an abstract schema.ts. And this will also have a schema decorator. And we can export this class called abstract document. And you probably guessed it already, this is going to be including our ID property, which we know exists on every document. So this is going to come from types dot object ID. Types come from Mongoose. And we also need to provide the prop decorator here to specify this is a property, and we're going to tell it its type here. So in this case, schema types. It'll be schema types dot object ID. So now we have an abstract document that all of our other documents can extend. So we'll extend abstract document here. And now we don't need to include the ID property, we get it for free. All we need to do is provide our other properties. So in this case, we of course know that's going to be an email, which is a string. And for a string, we don't need to provide the type to the property, it's already inferred. And we have another property for the password, which is of type string. Now lastly, we need to export the actual schema here. So we'll export the user schema, where we call schema factory create for class. And then we pass in the document. So we'll pass in the user document here. So now that we have our user schema, let's open up our users module, and we're going to add a new import section here. So our import section is going to import the Mongoose module for feature. And this is where we actually provide all the schemas that we're working with. So in our case, it's only going to be one. We know it's going to have a name. So we're going to give it the name of our user model because we want the collection to be called users. And then the schema itself comes from the user schema. So notice the name here comes from the model we set up for GraphQL. And the schema comes from the separate schema file that we created. Okay, so we have a schema now, and that means we are ready to actually create a repository for our users so that we can interact with this database. So let's go ahead and create a new users repository.ts. And this will be an injectable class that we can inject into our service. So we'll export a class called users repository. Okay, and before we forget, let's actually add our users repository to our providers array so that we can inject it later on. So now inside our users repository, we can add our functions that we need to be able to create and find a given user in our database. Now these operations, creating and finding an entity in our database, these are going to be common operations that we want to do for multiple entities in an application. And we also have shared logic between that, such as actually fetching, creating, and common error handling. So it makes sense to have some sort of abstract repository that we can extend so we don't have to duplicate all of this logic. So let's go ahead and do that. In our database directory, let's create an abstract repository. So we're going to go ahead and export an abstract class called abstract repository, and this just means that no one's actually going to ever instantiate this class. This is just going to be a template for other classes. Okay, and we're going to take a type here. So we're going to specify that this type is going to be T document. So this can be any name. Okay, and this T document, which represents whichever document that we're actually working with, so a user or any other kind of entity, it's going to know, we know that it's going to extend the abstract document that we've created earlier, which if you remember, we know for sure will have that ID field, which Mongo will always populate for us. Now we're going to go ahead and have a constructor here where we have our actual model, which allows us to call functions using Mongoose and actually interact with the database. So this is a model from Mongoose, and we can specify the type here. So we know this type is going to be of that T document that is being passed in here. So now let's go ahead and add our first abstract method. So we're going to have an async create method. So we know this create method will of course take a document, and this document is going to be of this T document type, but we don't want to have to provide the underscore ID field because we want to auto generate that for all of our entities before we insert the document. So in order to do that, we can specify the type here will be omit T document. So we're going to have the T document, and we're just going to omit that ID field here. So this is going to be the document we get. It's going to be this whole T document without the underscore ID. And that's because we're going to actually populate that in this abstract method, so we don't have to do it in the service layer every time. So now inside this create method, I'm going to create a new const called created document. And this is going to be new this.model. And we can spread all of those properties that is being passed in from the document. And then we're going to specify that underscore ID property that we know we want. So this is going to be from new types dot object ID. So now we have this created document. We can call await created document dot save. Okay, and then we're going to wrap this await call in parentheses because we want to actually call toJSON on this. And the reason why we're calling this toJSON method is because by default, when we call save on this document, it's going to be a hydrated document with a bunch of other methods and properties specific to Mongoose on it that we don't need or want. So when we call toJSON, we get that lean document that we want. So lastly, we can go ahead and return this created document, and we do see an error about this type being potentially arbitrary related to the expected type. So I'm just going to go ahead and cast this to type unknown and then as tDocument, and this is just because I know for a fact that this will always return the expected document we have here, so we can cast this safely. Okay, next let's implement a simple find one method, and this find one method will take a filter query, which is going to be the actual query, and it's going to be based off of the tDocument that is passed in. And of course, we will return a tDocument if we find one. So let's set a const here set equal to the document, and we're going to call await this .model .find one. We'll of course pass in the filter query. We have a projection here with nothing that we want to project, but then we have an options object, and we're going to pass in this lean property, and this is the same reasoning behind calling toJSON. We don't want the hydrated document, but we just want the plain JavaScript object, which is much more performant for your queries when using Mongoose if you don't need that hydrated document. So next, let's actually check to see that we got the document back. So if we didn't get this document back, I want to actually log a message so that it's pretty clear that there's an issue finding a document. So I need access to a logger in this abstract class. So in order to do that, we can specify an abstract property up here, which just means that we need our child classes to actually instantiate this property. So this will be a logger of type logger from Nest.js common. So that now that we know we're going to have a logger, we can call this .logger.warn, and we can say document not found with filter query, and we'll provide the filter query. And so this will just give us a bit more information when our queries fail, if they do. And then lastly, we're going to throw a not found exception here and say document not found. Make sure we have the new keyword here. And if we of course do find the document, we can simply return it to our caller. So now we have two abstract methods implemented for all of our repositories to use. We can go back into our users repository and make use of it. Okay, so now to actually use this abstract repository, we'll simply extend the abstract repository, and then we need to provide the tDocument. So in this case, the document is the user document. Now inside of the class, we'll firstly have to provide that logger that the abstract repository expects. So we're going to declare a new logger from Nest.js common, and we'll provide the users repository.name here. Now, of course, we'll also need to provide the model itself. So we're going to call inject model from Mongoose, provide the user.name so it gets the correct model, and then we'll specify this is a type model, and of course, the user document here. Now we'll call super and actually pass in this user model, and make sure we've of course imported user properly. So now we have this users repository that's able to create and find documents. So let's go ahead and enter our users.service, and we can start fleshing out our functions here. So firstly, let's actually get access to the users repository. We'll inject this here in our constructor. So this will be of type users repository, and now we can actually use this in our functions below. Okay, so when we create a new user, the first thing that we want to do is actually validate that this user is valid. So our one business rule right now, you could say, is that we don't want to have two users with the same email. So let's go ahead and actually verify that. I'm going to create a new private async method here called validate create user data, which will of course take the create user data, which is of type create user input. Okay, and now what I want to do is I want to check to see, I want to call await this.users repository.find one, and I want to simply just see if there's a user here with this email that we're trying to use for our new user. So now we're calling our repository. If we look at find one, if we don't find a document with this filter query, we're actually throwing an exception. So to get around this, let's actually wrap this check in a try catch block. So we'll have a try catch block here. So what this means is that if we enter this second line here and we haven't thrown an error, so we don't enter the catch block, we know that this user query actually succeeded and there isn't a user with this email. So at this point, we know that a duplicate user exists, so we're going to throw an unprocessable entity exception and say email already exists. And in the catch block, there's nothing for us to do because what that means that this is a unique user and we are fine with creating it. So let's firstly call await this.validate create user data, pass in the create user data. And now we're actually ready to persist the user to our database. So in order to do that, we need a way to store our plain text password that's being passed in here. We definitely don't want to store this as plain text. That is a bad security practice. We want to hash that password so that it's encrypted. So in order to do that, we're going to quickly install a new package here. So pnpm or your whatever package manager you're using, install bcrypt. So now that we've installed bcrypt, we can actually hash this data. So in my import section here, I'm going to import star as bcrypt from bcrypt. Now in our create user function, let's actually create a new const called user document and set it equal to await this.users repository.create. And now if you remember, it expects a document of type user document without the ID. So we can simply pass in that create user data. So let's override our password with a call to bcrypt.hash, which takes in the value that you want to hash, so in this case is the password, and then the number of salt rounds, which is essentially the number of random characters we want to add on to this hashed value to make it a bit more secure. So now we've successfully saved our user in our database. We can return it to our resolver. But if you remember, our user's resolver should return the user model and not the document as we have now. So to do this, let's create a new helper method in here called toModel, which takes in a user document. So we have a user document, and it's going to return, we can say explicitly, it's going to return the user model. So all we're going to do here is map the document to the model that we have for GraphQL. So firstly, we have the ID, which if you remember right now is an object ID. We can simply call toHex string to turn that into a string like we expect. And then lastly, we're just going to provide the email, which is going to be just the email. Now you notice we don't pass the password into the model here, and that's because we do not want that leaving our service layer. That is a secure value that should stay directly in the domain that we're working with. So finally, we'll return this .toModel, pass in that user document, and now the resolver can correctly return that newly created user securely to the caller. And finally, we can implement our getUser method here quite easily. So it's going to be very similar. We'll have a user document, and we can simply call this.users repository.find one, pass in the getUser args here, and all we have to do now is return this.toModel with passing in that user document. So now we have everything we need to be able to create and find a user. Let's test this out in our GraphQL playground. Okay, so if you open up your GraphQL playground at localhost 3000/GraphQL, you should firstly see in the schema section here are different inputs. But most importantly, if you look at the doc section, you should see our create user mutation with the expected arguments and the query here we'd expect that can take in the ID and return us the user. So on the left hand side here, you can see a mutation that I've created where I'm passing in some create user data, the email and the password, and I'm saying I want the ID and email back. So if we execute this, we can see we have a successful response. And now if I go to a new query and I actually pull this ID off of the user we just created, and we have this user query here. We can enter in the ID, and we should see that we get the user back. Now, if I modify this ID so that it does not exist, we can see we have that document not found message with a 404 response. And in our logs, we can actually see that error message where the document is not found, and we can see the filtered query it's using, which is nice to see. Finally, if we open up Compass or a Mongo tool, we should actually see the user's collection here with our users saved, and of course our password is securely hashed. So now that we have a way to successfully create and find users, let's hook up our UI and our login and sign up form to take advantage of this. Okay, so now we're actually ready to set up our front end to communicate with our back end. And we're going to use Apollo Angular to do this. So in your terminal, go ahead and run npm install Apollo Angular, as well as Apollo client, and then GraphQL itself. Additionally, if you run into a warning about peer dependencies not being met, you can also use the -- force flag here to install these packages directly. So next, we're going to install some packages which will allow us to automatically create Angular services based off of our GraphQL schema. So we don't have to manually write code that will work with our queries and mutations. This will happen automatically. So let's go ahead and do that. We'll run npm install GraphQL codegen, GraphQL codegen / schema -ast, GraphQL codegen / TypeScript Apollo Angular, and lastly GraphQL codegen TypeScript operations. So it's a number of packages here, but this will allow us to save a lot of time in writing boilerplate Angular services. Next, in your TS config here, in your compiler options, in your lib key here, in the lib array, make sure that we add esNext.async_iterable, which is required for Apollo client to work properly. And now we can actually integrate Apollo Angular. So let's open up our app.module. And inside of our providers array, we'll have an object here where we provide the Apollo options. And we're going to provide using useFactory here to provide the configuration options for Apollo Angular in our whole application. So we're going to have an HTTP link here, which is of type HTTP link. In HTTP link, we actually don't want to import it from Apollo client. We want to import it from Apollo Angular /HTTP. So up here, make sure we import HTTP link from Apollo Angular. And then now we can specify a return object that has all of the configuration we need. So firstly, we're going to specify the cache that we want to use. So we're going to use the new in-memory cache here from Apollo client. Now, very importantly, make sure that your in-memory cache here is imported from Apollo client core and not just Apollo client. And then secondly, we're going to specify the link that we want to provide. So we're going to use the http link.create, and then we can specify the URI, which is where our GraphQL server is actually listening. Now, normally this would actually just be our local host running at port 3000 /GraphQL. Now, this would work fine. However, we're going to actually use a proxy in our application so that we don't need to specify the actual API URL for any of our URLs, but instead, we're going to specify that all routes to our API will be listening on this API route here, and then we can specify the actual name of the route afterwards. And the advantage of doing it this way is that we don't need to be dependent on hard-coded URLs. We can swap that out at runtime with a configuration at one spot. Now, lastly, don't forget we need to actually also provide a dependencies array here after our useFactory and actually inject the HTTP link here. Finally, Apollo Angular needs the HTTP client module, and we'll also use this directly later on. So make sure we import that here in our app module, the HTTP client module. So let's go ahead and create this proxy setup. So in our source directory, we're going to create a new file called proxy.conf.json. And then we're going to add a proxy configuration. So like I said before, all requests to /API are actually going to get forwarded on to the target here. So in this case, it'll be localhost 3000 for our local development. We can also specify secure false because we're not using HTTPS, and then a path rewrite so that when we do forward requests to this target here, we don't include the /API, but we rewrite it to not include it. So lastly, to actually use this proxy config, we need to open up our Angular.json here, and we need to scroll up until we find the serve object here. And we can see our configurations for production and development. So you could potentially have different proxy configurations for these different build modes, but in our case, it's going to be the same one for now. So we'll add the proxy config to both serve configurations. Lastly, for the proxy to take effect, you're going to need to restart your development server. So make sure you just cancel the existing server and start a new one up with ng-serve so that it works properly. So next we're going to set up our configuration for that GraphQL code generation package that we installed earlier so that we can actually automatically generate Angular services to work with our GraphQL queries and mutations. And with the correct configuration, we can actually get our code to listen to our GraphQL server for updates to our schemas so that we have to do very little work. So to get started, let's create a codegen.yaml file. And in this file, we're going to define a few keys. So the first one will be the schema itself that we want to derive these auto-generated services from. Now, this could be a schema that you have downloaded locally, or more importantly, we can actually just provide a URL here for the schema to automatically be created from our GraphQL server. So let's do just that. Let's provide that local GraphQL server listening on port 3000. And then we specify the documents that we want to generate our services from. So this will be actual GraphQL queries and mutations that we define based on certain operations. So in our case, we can specify a glob here that says anything in the source directory that has a .graphql extension. We want to use that to derive our documents from. And then we will have the generates key here, which will tell the code generator to actually generate this file called generated types.ts. It could be anything we actually want, but this is a good name in the source directory. And of course, then we have to specify the plugins that we need for this to actually work. So we'll add the TypeScript plugin, TypeScript operations, and TypeScript Apollo Angular. So this is everything we need to configure the code generation. Next, let's actually go into our package.json, and we can create a script here and have this automatic code generation run in the background and listen for any updates to our schemas. So I'll have a generate command here, which we'll call GraphQL codegen watch. So now we're actually ready to test out this automatic code generation. But first we need to actually create our first document to allow it to work properly. So in our app directory auth signup, we actually need to create some code here that will allow us to trigger the create user mutation that we set up earlier. So what we have to do is create a create user.mutation.graphql file here. And now all we have to do is actually just specify the mutation that we want to execute, and the code will automatically be generated from this. So importantly, I actually have a plugin here, the GraphQL plugin in VS Code. So if you look for this extension called GraphQL from GraphQL Foundation, we can actually configure this to listen to our GraphQL server and have it use automatic code completion and validation based off of our schema. So in order to have this plugin actually pick up our GraphQL schema, we'll create a new file called .graphql rc.yaml. And inside of this file, we can actually copy over these first two properties from our codegen.yaml, the schema and the documents we want to listen to. And this will allow the plugin to automatically pick up our schema. Lastly, make sure you actually restart VS Code after we create this configuration file so that VS Code and the GraphQL plugin can actually work properly. So once you do restart, you should see that we actually start to get auto completion and validation as part of our schema. So we can actually create our first mutation here called create user. And of course, we're going to need to take create user data here, which will be of type create user input. And as you can see here, we have this auto completion coming, which is great. And we can specify the fields that we want to get back. So we're going to have the ID and the email, and we can actually see complaining here that we don't have the create user data it expects. So let's go ahead and provide that create user data coming from the create user data variable that we just specified here. So now that we have this mutation created, we want to actually use it inside of our component. So in order to actually make use of this mutation that we've created, open up a new terminal inside of your Angular folder, your Angular frontend app, and let's run that script that we created earlier, npm run generate, which will actually use GraphQL codegen with the watch flag. And what it's going to do is it's going to look at our schema at localhost 3000/GraphQL and generate Angular services based off of any queries or mutations that we've written in our app, and watch for changes in real time. So we don't need to continually run this command. We can just leave it in the background. So now if we open up our code editor and we look inside the source directory, we should see this new generated types file here. And very cool, we can see that it's actually created all of these types from our GraphQL schema. And most importantly, it's actually even created a Angular service here that we can use in our components to make this call to our server. So let's go ahead and actually use this newly generated service. Let's open up our signup component. And firstly, we're going to go ahead and inject it inside of our constructor, because this is an Angular service that's been provided to us. We can inject it into our component. So I'm going to call this create user GQL, and it's going to be of type create user GQL. So now in the signup function here, instead of simply just logging out the email and password, we're going to call this .createUserGQL.mutate, and then we're going to pass in our create user data. So it expects create user data with email and password, and you can see we get this type information here already, so that TypeScript will validate our calls, which is also very nice. So by default, when we call mutate, we're not going to actually make the call. It's not until we call subscribe that we actually do make this call. So for now, we'll just have an empty subscribe block so we can test this out. So in your browser, go to localhost 4200 where our app is running, and you should see that we actually have an error about our generated types file complaining it doesn't have an override modifier. Now, in order to get around this error, let's go ahead and open up our tsconfig file, and we're actually going to add a file here, or a property here, no implicit override. We're going to change this to false so that we don't need to explicitly provide that override keyword. And after you make that change, you might have to restart your development server again to get rid of that error. But after we do, we should go back to our web app and see everything running properly. And then we can go to our sign up page. So we should now be able to see our web app properly. And if we navigate to the sign up page, we should see our form as always. And now let's open up our network tab here so we can actually see our call to the backend to sign up. And then I'm just going to use any email here with a random password, and we should be able to click sign up and see a GraphQL call here. And we can see the operation here with our payload, with our email and password, which is great. And then we can see the response that we got back. This was a 200, and we're getting our newly created user with our ID, email coming back from the server. And of course, remember, we're not including the password. So this is great. We can see the user getting created. And finally, if we actually look at our database, we can see that the saved user is shown up here. And if we want to create another one, we should see that entry populate in our database. So we can see how easy it is to use these automatically generated services to make calls to our backend and really reduce a lot of the boilerplate we usually have to write in this data fetching logic. Now that we have a way to actually create new users with our signup form, we need a way to actually authenticate that the user's credentials in this login form, or after we actually create the user, is authenticated. So in order to do that, we're going to build out some authentication logic in our backend next. Okay, so let's get started building out authentication for our app. So in our backend, I'm going to open up a new terminal here, and I'm going to run Nest generate module auth so that we create a new auth module. I'm also going to generate a auth controller. So Nest generate controller auth. And then lastly, we're going to generate a service, so an auth service here. So we're going to go ahead and install some dependencies here. So we're going to add Nest.js passport, and then passport local. Lastly, we're going to install the types for passport local here as a dev dependency. And then we're going to go ahead and install Nest.js JWT as well as passport JWT so that we can have a JSON web token approach for our app. And finally, we'll install the types for passport JWT. So before we set up JWT functionality in our app, we're going to actually add two new environment variables to our .m file. So I'm going to go ahead and add a JWT expiration and set it to 3600, which will represent the amount of time in seconds that our JWT will be valid for. And then we'll have a JWT secret, which is just a random string of characters that will be signing our tokens, and then will be used to compare the tokens that are sent to ensure that they are indeed valid. So like you can set those environment variables, and then in our app.module, we can of course verify that these exist before the app starts up, because we of course don't want to start our app in an environment where these don't exist. So we'll set JWT expiration to joy.number.required, and JWT secret should be joy.string.required. And this here, of course, should be JWT secret. Make sure we spell that correctly. So now we can actually go into our auth.module and start setting up our JWT functionality. So let's add an import section here, and we will call JWT module.register async. And we're going to provide a use factory to configure it. We'll of course need the config service to get access to those environment variables we just created. Then we're going to return an object here. So firstly, we're going to provide that secret value by calling config service.get, which is a string, and called JWT secret here, so we get the secret value. Next, we're going to provide sign options, and this is where we can provide that expires in property. So we're going to call config service.get JWT expiration, and we're wrapping this in a template literal because we need to provide the S here for seconds so that it correctly expires in the right number of seconds. And then lastly, we're going to actually inject the config service here. So now that we have JWT functionality set up, let's go ahead and start building out some of our auth strategies. So our auth strategies are built off of passport.js. So we're going to create a new folder here called strategies. We're going to keep these strategies. So we're going to have two strategies, one for local, which is just an email and password, and the other will be for the JSON web token. So let's start with the local strategy. So we'll have a local strategy here, which will be an injectable class. So we'll export a class called local strategy, and this will allow our code to accept an email and password from the client. So make sure we extend passport strategy here and pass in the strategy. Now this is where we actually pass in which strategy we want to use. We can see we have the JWT one here and the local one. So this will be local. And make sure you import passport strategy from Nest.js passport. So now within here, we can actually have a constructor. And importantly, we're going to make a call to super where we actually specify the username field that we want to use, because by default, it'll take a username to validate any incoming requests, but we want to actually use the email field as our username. And finally, we have an async validate method here that will be provided the email, or in this case, the username field, and then the password. So this validate method will get called automatically by the passport strategy to ensure that these credentials are valid or not. So it's up to us to determine that. We have an email and password, and we need to determine if these are valid based on incoming request. So to do this, we're actually going to offload this to the user service which actually knows about our users and their emails and passwords. So let's actually go to our users.service in our backend here. And let's actually create a new async method called validateUser, which will of course take that email and password, both strings, and it's going to actually check to see if these credentials are indeed valid. So we'll of course check to see if the user actually exists with this given email, which will be the first step. So we'll look to see if we have a user with this email from our repository, and then we're going to check to see if the password is valid. So I'm going to create a new const here called password is valid, and we're going to set it equal to await bcrypt.compare. So bcrypt.compare lets you pass in the value that you want to check against, so the password, and then the actual hashed password. So in this case, we have that password on the user document. So we can actually see if the password is not valid. Well, of course, if the password is not valid, then we want to throw an unauthorized exception and say credentials are not valid. And if the user is indeed valid, so the password is correct, we will return this .toModel with the user document. So we actually do return this user without the password, of course. And this is important because in this local strategy here, whatever we return from this validate method will actually get added on to the request object as the user property. So let's actually make use of this new function here in our constructor. We will inject the user's service. So in this validate method now, we can simply return actually this user service validate user and pass in the email and password. Now, in order for this to work properly, we're actually going to have to go into our users module and make sure we export our user service so that it can be injected inside of our auth module. So we've exported the user service. Now we need to actually go into the auth module now and actually make sure we import the users module so that we get access to it here. Now next, we actually need to set the local strategy as a provider here in our providers array for the auth module so that our application knows about the local strategy. So now that we have our local strategy created, we need to actually create a corresponding auth guard that we can use in our controllers to actually trigger the strategy to run. So let's create a new guards folder, and inside of this guards folder, I'll create a new local authguard.ts. And this is simply going to export a class called local authguard, which is going to extend authguard from Nest.js passport, and then we pass in the name of the strategy that we want to use. So in this case, it's local strategy. So we pass in a string local here. So now that we have this auth guard, we can actually use it in our auth controller. Now our application is going to use HTTP only cookies as its authentication mechanism. So we're actually going to put the JSON web token inside of an HTTP only cookie instead of storing it in local storage or any other mechanism because it's the most secure way to store a JSON web token. So let's go ahead and get started and see how we can actually do this. We're going to have a post route here that we're going to call login. So we're going to have a login function, and this function firstly is going to need to be able to get the current user on our request. Now, in order for that to happen, we're actually going to trigger our auth guard. So we know we have our local auth guard that will run whenever this route is called. So if you remember in our local auth guard, it's going to run the local strategy, which will, if the user is valid, attach this user from our user service to the request object. So I actually want to get access to that user object on the request object in this login function here. Now there's actually multiple places you might want to do this to be able to get the current user in the current context. So in order to do that, I'm going to create a new function here in the auth directory called current user.decorator. And we're actually going to create a decorator that will allow us to extract the current user. So we're going to export a const get current user by context. And so this function is going to take the execution context and it's going to return a user. So in this function, we're first going to check to see if the context.getType is equal to HTTP, because we're going to support both HTTP requests as well as GraphQL requests using this function here. So if it is HTTP, we're going to call context.switch to HTTP, get request, and then return the user off the request. Otherwise, we're going to assume that the context is GraphQL. So we'll call GraphQL execution context.create, pass in the execution context, and then we can simply return context.getContext, and then pass in the request.user. So now we have a function that will work for both HTTP and GraphQL requests. Now lastly, to actually use this as a decorator, we'll export a const called current user here and call create param decorator from Nest.js common. And this provides us with a callback with a data arg, which in our case we won't use. So we can just use an underscore, and then we'll have the context parameter, which is of type execution context. And then we can simply pass this off to that function we just created to pull the correct user off by context. So let's go ahead and use that here. We will call the current user decorator, which we know will return us a user object. And secondly, we actually also need access to the response object. And this is because we want to set a cookie on the response before we send it back to the client. So make sure you import the res decorator from Nest.js common. And we're also going to add this pass-through property here, set it to true, which just means that it goes through the normal Nest.js response processing pipeline, which we want to happen. So this is a response, and we import the response from Express up here. So make sure we import that properly. So now we have the current user and the response. I'm going to call await this.auth service, which we actually still need access to. So let's go ahead and inject that now. So now we have access to the auth service. We're going to call login, which we haven't implemented yet. But this function will take the user and the response. And then after that's done, we'll call response.send and send back the user. So let's actually open up the auth service. Let's actually implement that login function now. So this will be an async login method that we know takes the user as well as the response. And remember, this is imported from Express. So the first thing we need to do in here is actually create a token payload, which will be the payload that we sign the JSON web token with. We can actually export the interface here, token payload. And inside this token payload, you can include any information about the user, maybe even put the whole user object on the payload itself if you don't want to make a database call directly. But in this case, I just need to put the user ID. I don't mind having to go back to the database if necessary. So we'll just put the user ID there. And now in this token payload, we can extract the user ID from the user ID property here. So next we need to generate the expiration date for this JSON web token. We'll have an expires variable here, and we'll set it equal to the current date. And then we're going to set expires.setSeconds. So we're going to push the expiration date forward to, well, the current seconds on it, plus now I want to add the JWT expiration that we've defined as an environment variable. So in order to do this, as you probably have guessed, we're going to need access to the config service. And now I can call this.config_service.get and pass in that JWT expiration. So finally, we have everything we need to actually sign the token. Let's go ahead and import the JWT service, which we need to use to sign the token. So this will be JWT service, and we import this from Nest.js JWT. So now we can actually create a token. So let's set it equal to this.jwt service.sign, and we'll pass in the token payload. So now we've minted a new token for this user. Our last step is to actually set the token as a cookie for the user so that they're able to use it for later requests and remain authenticated in our system. So we have that response object we'll call response.cookie. Now this takes the name of the cookie that you want to set, so we'll give it the name of authentication. Then it takes the actual value, so we'll pass in the token, and lastly some options. So we're going to set this as HTTP only so that you won't be able to actually see the cookie or manipulate it in the browser, but it's only sent for HTTP requests themselves, which makes it more secure. And then we pass in the expiration date for the cookie, which will be conveniently the same amount of time as the JWT expiration. So now to actually test out this login functionality, I have a post request for HTTP localhost 3000 auth login, and I've passed in an email and a password here after I've gone ahead and created an account. So if I send this request off, you can see we get the user response back. But then if we look at the cookies section here, you can see that we get an authentication cookie set properly with the HTTP only cookie set to true, which is just what we want. So now we have a way to authenticate users in our application. Let's continue building out our authentication so that we can actually make use of this HTTP cookie and secure our routes. Okay, so now that we actually want to use this JSON Web Token cookie, we need to install a new package called Cookie Parser. So I'm going to pnpm install Cookie Parser, which will allow us to actually parse incoming cookies very easily and extract that JSON Web Token. I'm also going to go ahead and install the types for it. So types Cookie Parser, and make this a development dependency here. So now that we've installed Cookie Parser, let's open up our main.ts for our application. And we're going to actually use this Cookie Parser and attach it as a global middleware in our application here so that we're always parsing incoming cookies. So right before we call use global pipes, we're going to call app.use, and now we can call Cookie Parser. So we're actually going to import star as Cookie Parser up here from Cookie Parser. So make sure we import that correctly, and then we can call Cookie Parser, and now we can correctly parse incoming cookies. So next we need to actually create a new strategy to work with this JSON Web Token cookie. So we'll create a new strategy called jwtstrategy.ts. Okay, and this is going to be an injectable. So we're going to export a class called jwtstrategy, which will extend passport strategy just like we did with the local strategy. But now instead of importing strategy from passport local, we're going to import it from passport JWT. So in the constructor, we're going to need to get access to the config service. So import the config service as well as the user service. So make sure we import the user service. And now in the constructor, we're going to make that super call as we did before. And so now we're going to provide a new property called JWT from request, which essentially allows us to provide the JWT a custom path to it based on the request object. So we can call extract JWT from passport JWT dot from extractors and pass in an array here where we actually get a function that has access to the request object that we can import from Express as always. And now we can actually return the request dot cookies dot authentication. And notice we're using this question mark operator here so that if the request cookies doesn't exist, this won't fail here. It'll just return undefined. But if it does exist, this is where that authentication cookie will be living on the request object thanks to Cookie Parser. Now lastly, we still need to provide secret or key here. We can call config service.get and then of course call JWT secret so that we can actually verify that this JWT provided is in fact one issued from us. Now the last step is to actually ensure that the token payload, which contains the user ID, actually corresponds to a valid user. So as we know, we're going to be calling this validate method each time that this strategy is run. And inside this validate method now, instead of getting the username and password, we're actually going to be passed the token payload, the decoded token. So we know that we're going to return this .userService.getUser and pass in the ID. Well, of course, this will be the user ID. So if the user does exist, we'll simply return it from our user service. If not, we know the user service will throw a not found exception from our repository layer, and this strategy will fail. So as we've done before, make sure we add this new JWT strategy to our providers array. And to make sure we can actually use this as a guard, we'll create a JWT auth guard in our guards folder, and we'll export the default class JWT auth guard, which will extend auth guard. And now we pass in JWT for the correct strategy. Now finally, we have everything we need to now properly implement authentication in our app. However, we don't have an auth guard to work with GraphQL, and this is very easy to fix. We'll create a new auth guard called GQL auth guard, and we'll export a class called GQL auth guard, and we're going to still extend auth guard from Nest.js passport, and so this is still going to be a JWT auth guard. However, we're going to override the get request function in here, which gets a execution context as a parameter. So make sure we import execution context, and then we're going to firstly create a GraphQL context. So GQL execution context.create, pass in that context we're provided, and then we can simply call context.getContext and then pass the request object. So now this GQL auth guard will work with our JWT strategy. All we had to do was just tell it where to look for the request object. So now inside of our user's resolver, we should be able to decorate this get user query here with a use guards call, and then we can pass in that GQL auth guard. So now this get user controller route here is protected by our GQL auth guard, and it will require a valid JSON web token cookie in order to be executed. So we can see this in action if we go to localhost 3000/GraphQL, and we try to query a user by ID here. When we execute this query, we can get that unauthenticated 401 response back, which is what we'd expect. However, in Postman now, if we first log in, so we get that authentication cookie set, and then we call localhost 3000 GraphQL here, we can then change our body to a GraphQL, and simply let's just copy over this whole query and look at our response. You can see we just get a 404 response because this user has not been found, but you can see this request was actually executed because we did have that authentication cookie set for us by Postman in this request. Okay, so now it's time to actually hook our UI up to this new authentication so that we can actually authenticate the user and get that JSON web token back in our UI. So let's go ahead and open up our login folder in our UI, and now let's create a new login service, which will actually handle this external call to the backend. So this login service will be injectable, and we'll call provided in root so that it can be used anywhere. And so we'll export a class called login service. Now this login service will of course need to inject the HTTP client that we'll use to actually make the REST request to our backend. So let's expose a login function. Now this login request actually conveniently will be the same object as our create user input from our generated types, which we know is simply the email and password. And then we can simply return this.http client.post. Remember, this is a login request, and we can actually provide the type here of the return type, which we know is the user. And now we can provide the actual URL to the endpoint. So as we know before, we're proxying our requests that are gone through /API. So we can use /API/auth/login. And remember, our proxy will automatically convert this API route into the actual real API URL at runtime. And lastly, we'll provide the login request that we want to send along. So this is everything we need in our login service. Let's go back into our login component so we can actually inject this. So in our login component, we're going to go ahead and, of course, inject that login service. So in addition to the login service, we're going to inject the router. so that we can navigate the user after they did log in. So now in this login function, instead of just logging out the email and password, let's first go ahead and actually change this variable here to create user data, which is a type create user input. And then we can remove this log statement here and actually call this.login service.login, provide the create user data. And then since this is returning an observable, let's subscribe to this so that later on we can actually navigate the user after they log in. So back in our UI here, we're on our sign up page right now. So let's go back to our login page. So now on our login page, you can use any account that you've created that exists. So we can first, let's open up our network tab to see this call. And after we log in, we can see our login response completed with a 201. So we can get that user response back, which is great to see. But we're most interested in this cookies section here. So we can see, if we expand this out a bit, response cookies, we can see we get that authentication cookie back with a value of the JWT and expiration from our JWT expiration date. So this is great to see. So now we actually have this cookie and all subsequent requests from our UI will be authenticated. So now that our authentication is working correctly, let's go ahead and create a new home component that will be hosting our homepage content. So in our root UI directory, I'm going to call ngGenerate module home. So this will create a new home module for us. And then I'm going to create a home component. And for now, this will just have nothing inside of it. But what I want to do is I want to open up my app routing module, and I want to set the home page. So in this case, the path will be just nothing. It'll be essentially the root URL for our app. I want to set the component equal to the home component. But now what I want to do is I want to add a guard to the home component, so that if you navigate to the home component, the root directory or the root URL, and you're not authenticated, then I don't want to show the home component. I want to navigate back to the login component where the user could either log in or create an account. So in order to accomplish this, we need to create a new guard in our application, which will determine if the user is authenticated or not. So in our auth directory, let's go ahead and do just that. Let's create a new auth guard. So I'll create a new file called auth.guard.ts. And this will be an injectable class. Just like our service earlier, we'll provide it in root so that we can use it anywhere. And we're simply going to export a class called authGuard, which implements can activate, which is a special interface from Angular Router, which will essentially implement a function called canActivate, which will tell Angular whether or not this user can access the route in question. So inside of this authGuard, we now need to specify whether or not the user is authenticated. And I actually want to abstract this determination, this logic inside of a service, which could then be injected or used in any other component to determine if the user is authenticated or not. So to do that, we're going to create a new auth.service.ts. And the benefit of this is that we can actually determine if the user is authenticated anywhere in the app from this auth service. So we'll export a class called auth service here. And inside of this auth service, we're now going to implement a method called isAuthenticated, which will determine if the user is currently authenticated. Now, one of the drawbacks of using HTTP-only cookies for our authentication mechanism is that we can't necessarily determine right there and then if the user has that cookie set. Whereas if you were storing your token in local storage or memory, you could quickly just check to see if it exists there. That does not work with HTTP-only cookies. Instead, we need to actually reach out to our server to tell us if this cookie is set and if the user is authenticated. So in order to accomplish this, we can actually implement a very simple route in our auth controller in our backend to determine if the user is authenticated. So let's go ahead and do that really quickly. We'll have a use guards here, and we'll pass in the JWT auth guard. And this will be a simple get route. So use the get decorator So it's going to be a very simple function called isAuthenticated. And all we have to do is return true. And the reason is because we've already decorated it with this use guards here. So if the user is authenticated, at this point, we know that they're valid. We can just return true. If they are not authenticated, we know that this JWT auth guard will have thrown an error so that they are not authenticated. So this is just what we need in our auth service. Let's go ahead and firstly inject the HTTP client so that we can actually reach out to our auth service. And now in the isAuthenticated, we're going to return this.http client.get. We of course know that this returns a Boolean, if true, if authenticated. So we can call API/auth. It's a simple get route. And now I want to actually pipe on this response. So piping allows us to add new functionality to this observable chain. So firstly, I want to add map here from Nest.js. Inside of this map function, we're going to provide a callback. So inside of this pipe function, I actually just want to provide a catch error function. So this comes from Nest.js. And what this will allow us to do is that if a error is thrown when we call this route, which will happen if we're authenticated, then this function or this whatever we provide in this catch error handler here will get called. So if we're unauthenticated, if an error was thrown when we called our route, then I simply want to return an observable with the value of false, which means we are not authenticated. So to summarize, if we are authenticated and we have the HTTP only cookie, we will return true from this observable. Otherwise, an error will be thrown, we'll catch it, and then we'll return false. So now back in our auth guard, we can actually inject firstly the auth service we just created so that we can offload that logic there. And then let's also inject the router. So let's add the canActivate function here. Return this.authService.isAuthenticated. Now I want to actually pipe another observable in here, and we're going to use tap from Nest.js, which allows us to use essentially as a side effect to this observable. So I want to check to see if we're authenticated. So remember, this original observable will return a true or false Boolean from this authenticated variable. So now we know if we're authenticated, true or false. If we're not authenticated, then I want to navigate. So we'll call this router.navigate to our /login page so that the user can correctly log in or create an account. So finally, we can go back into our app routing module here, and underneath the component, we can add a canActivate property, which allows us to specify any number of auth guards. So we'll provide our auth guard. Okay, so now to actually test this functionality out, we can open up our browser, and if we go to our home page, we can see that we have the homeworks text, which means that we're authenticated and we are actually displaying the home component. And if we actually look at the network tab, when we refresh the page, we can see that auth call to see if we're logged in. And we can see we get the simple response of true back. However, if we open up an incognito window or a new browser where our cookies aren't set and we try navigating to the home page, we see we're automatically redirected to the login page because we don't have that cookie set. So we can see our auth guard is working just as we'd expect. So right now, if a user types in any other route to our web app, you can see they're not actually redirected back to a login screen or any other page. They're just kind of redirected back to our home page, which isn't great. So in order to get around this, we're going to add another route here for path **, which is a wildcard, which essentially means if we haven't met any of these other paths and we're matching this path, then I want to redirect to the home page or the root URL here, which is where our home component lives, and our auth guard will correctly run and navigate the user accordingly. So now, if we were to try to go to some page that doesn't exist, we're navigated to the home page. But if we try the same thing in an environment where we don't have that cookie set. So incognito, I tried going to a different page, or correctly navigated to the login screen. So next, let's improve our web app a bit by adding the option to log out and to actually navigate to the login and sign up screens directly. So to do this, let's open up the header component again. So we have our header component here. And now in the header component, I want to actually inject the auth service directly in here because I wanted to determine if we're logged in or not and display content conditionally based on that. So essentially what I want to do here is to declare a new observable called isLoggedIn. Observable here that takes a Boolean, and I want our header template or our header HTML to be able to listen to this and display a logout text or login text based on the current auth state. Now, as of right now, our auth service is only able to directly call our backend to determine if we're logged in. And I want this header component to be able to listen to changes in our auth state from our auth service. So in order to do that, what I'm going to do is I'm actually going to create a new observable or a new subject in here called authenticated. So this will be a private read-only property. We'll set it equal to a new subject from Nest.js of type Boolean here. So now we can actually expose a public observable by calling this.authenticated.asObservable. And what this allows us to do, this pattern is great because it exposes this observable to the outside world, but it means that they can't actually emit events on the observable. We only emit through this private property here, which can only be done in this class directly. So now in our isAuthenticated function, before we actually return here, in our pipe function, I want to add a new side effect here. So as we've done before, I'll add that tap function. So inside of this tap function here, all we need to do is essentially call this.authenticated.next, and we can specify true. And the reason why we don't need to check the Boolean here is because we already know if an error is thrown, we're going to go straight to the catch error pipe. And this won't even get executed. So we automatically know if we're in this tap function here, we know we are authenticated, and we can emit true on our observable. So now back in our header component here in our constructor, we can set this.isLoggedIn equal to authService.authenticated so that when that observable emits, this one will as well. And now inside of our header component.html, we can build out the second part of our nav here. So we're going to have an unordered list. I'm going to give this a class of nav here. And now we can have a list item. And inside of this list item, I'm going to have a div element here. And this div element is going to have an ngIf property on it. And we're going to say, in this ngIf, we're going to check to see is logged in, that observable. We're going to pipe it as an async observable, which it is, so that we can actually unwrap that value, unwrap the observable. And we're going to say, if it's true, then we're going to execute the following block, else we're going to execute the login block. So if we are logged in, we're going to have an anchor tag with a click listener, and then we're going to specify an onLogout function that we can create in a second. But then we're going to have logout text here that just says logout. So this is if we are authenticated. If we're not authenticated, then we're going to create an ng template here with the hash of login, which corresponds to this else block here. So only if that condition is true, then we're going to have an anchor tag here, but we're going to specify the router link and set it equal to /login. And then we can provide the login text here. So we'll have to go into our header component now and add a onLogout function. For now, we can just keep it empty. And lastly, let's go into our header component.css. And I want to just provide this unordered list. I want to set the list style type to none. And so now if we go back to our browser, we should see that we have this logout link up here that is available to us. However, if we were to go to our other browser and navigate to the home page, we can see it's labeled as login because we are not logged in yet. So now to actually implement this logout functionality, we're going to need to handle this on our server side, because really what we want to do is we want to clear that authentication cookie that we set when we first logged in. So as this cookie is only sent for HTTP requests, we need our server to handle this. So let's go ahead and do that. Let's open up our auth.controller and let's create a new logout route here. So I'll create a new logout route. This, of course, will still have a use guards of JWT auth guard, because you still need that authentication cookie to proceed. And we'll have an async logout function here. Now we're still going to need access to the response, because we need to get access to the cookies. We'll provide that pass-through property as true here. And we'll set this equal to the response object. So now inside of here, we're going to call this .authService.logout, which we haven't implemented yet, but we'll pass it the response. And then we're simply going to pass response.json, an empty object here to specify that it succeeded. So now in our auth service, let's go ahead and implement that logout functionality. It will be very simple. It's going to be a standard function here that takes the response object, and all we're going to do is actually just override the original authentication cookie we set. So now we're just going to set it equal to an empty string. We're going to set HTTP only to true, and for expires we can just provide new date set equal to right now, so that it will expire as soon as we reset it. And lastly, I just realized we don't even need to make this asynchronous. So now we have a logout functionality on our controller, and we can use it in our UI. So let's go ahead and head back into our auth service in our UI, and let's create a new function to be able to log the user out of our application. So this will be called logout, and we're simply going to call this HTTP client.post. And remember, this is API/auth/logout. And we're not going to provide any body here, so we can just use an empty object. And then lastly, we're going to subscribe to the result of this call here. And we're going to call this .authenticated.next to false, because we're no longer authenticated. And then I want to actually navigate the user to the login screen. So in order to do that, we need to get access to the router up here. So let's inject that. So now we have the router, we can actually call navigate and go directly to the login screen when we log out. So let's go back to our header component and actually wire this up. We'll call this .authService.logout when we do click that logout button. So now in our UI, we should be able to click logout and get navigated back to our login screen once we log in. And now I want to actually navigate us back to the home screen when we log in or create a new account. So let's go ahead and do that. In our login component, let's handle this first. So we need to actually just inject the router in here. So in our subscribe block, after we successfully log the user in, then we're going to call this .router.navigate, and we can simply pass in the root URL or our home screen here. Now let's go ahead and actually do the same thing for our create account. Let's go ahead and copy the subscribe block, because we're going to do the same thing for our sign up component. After we successfully create the user's account, we want to navigate them to the home screen. So we'll have to inject the router again. So once we have access to the router here, in our subscribe block, we'll call this .router.navigate, and of course just pass in the root URL, our home screen. So now back in our home screen, after we enter a valid email and password and we're authenticated, we should get navigated back to our home screen. Lastly, back in our header component, I want to actually add one final element to our navigation to make it easier to users to navigate to our sign up page. So what we're going to do is we're going to create a new list item here, and inside of that we'll provide an anchor tag. Now this will have the router link set to /signup, and we can have text here say sign up. Now for the ngIf here, we essentially want the opposite of what we have up above. So we can just copy this existing logic, paste it in this ngIf, and let's just revert it here. So if we're not logged in, then we do want to expose this sign up link here. Now finally, in our header component CSS, let's add a little bit of styling to our nav list so that it looks a bit nicer. I'm going to set display equal to flex, and then flex direction will be row here. Lastly, I'll give it a little bit of a gap of 1.5 rem. So now if we go back to our UI, we can see this login and sign up link here. And we can easily switch between the two. And after we do indeed log in, we can see it disappear. Now, after we actually create the user using this create user mutation and try to navigate to our homepage, we won't actually be authenticated yet because we still haven't called login and gotten that JSON Web Token cookie. So to get around this, we're going to go ahead and actually log in as soon as we do create this user. So let's go ahead and inject the login service, which we'll use to actually log in. And then I'm going to change this variable here to create user data, because as we've seen before, this data that gets passed in is actually of type create user input from our generated types. So now we can just pass this create user data object entirely. And after we execute this mutation, we want to immediately log in. And we want these two observables to happen sequentially. So we want to first create the user and then log in right after that's complete. In order to do this, we're going to use the concat map function from Rx.js, which lets us combine observables and still have them execute in the order that we define them. So we'll first create the user and then we'll execute whatever observable we return from in here, which in this case we know is going to be this.login service.login. And we can pass that same create user data so that now by the time we're in the subscribe block and we navigate home, we will have that JSON Web Token cookie. So in our app, we should be able to log out, navigate to sign up, and then we can sign up under a new account and see that we are redirected to the home page and have authentication. So now we're ready to actually start building out the bookmarking functionality of our application now that we have authentication all set. So let's go ahead and open up a new terminal in our backend here, and let's do nest generate module bookmarks. So this will create a new bookmarks module for us. And while we're at it, we'll go ahead and add a new bookmarks resolver. And lastly, we'll do a service for bookmarks. So now in our bookmarks directory, we should have a module, resolver, and a service. The first thing we're going to go ahead and do, as always, is set up the model to define what this bookmark will look like in code. So because we've already set up our abstract classes for working in our backend, this is going to be a lot easier than when we first did this with the user. So let's go ahead and first create the bookmark.model.ts. So this, of course, will be an object type, as we've seen before from Nest.js GraphQL. We'll then export a class called bookmark, and this will extend the abstract model that we've already created, which, if you recall, all it has is that _ID field, which will be our Mongo ID for this entity. We'll have a read-only name property here of type string. Then we're going to have another field for the user ID that actually created this bookmark. And lastly, we're going to have a field here which will be an array of strings, and these are going to be the actual links that we have in each of our bookmarks. So you can think of these bookmarks as folders where you can keep any number of links inside. So this array of strings here will be the URLs for each of these links, which we'll then use to gather metadata about each URL. And while we're here, we're going to go ahead and also create our bookmark.schema.ts. So this is going to be a very similar structure to our user, where we're not going to specify a version key. And then we're just going to export a class called bookmark document, which will of course extend the abstract document we've created before. So we're going to have those same three properties as in our model. We're going to have the name, which is of type string. Then we'll have the user ID of type string. And lastly, we'll have the array of links, which is an array of strings. And finally, down below, we're going to go ahead and set a const called bookmark schema, which will be set to schema factory .create for class, and then we'll pass in the bookmark document that we just created. So now that we have this schema to work with, let's go ahead and create the repository. So that we're going to create a bookmarks repository.ts. So this will be an injectable class so that we can use it in our service layer. So let's put a class called bookmarks repository. And it's going to extend our abstract repository that we've created. We're going to pass in the bookmark document here. And now, as we did with the user repository, we're going to have to set the logger. So we'll set the logger equal to new logger from Nest.js common and pass in the name of the class. So in this case, we can do bookmarks repository.name. And then finally, we're going to provide a constructor where we actually inject this model so that our abstract repository can use it. We'll pass in the bookmark.name from the model, call this bookmark model, which will be a type model from Mongoose, and then we'll pass in the bookmark document here. So lastly, don't forget to call super and then actually pass up this bookmark model. So now we'll go into our bookmarks module here, and we'll provide this bookmarks repository in our providers array here. We'll then have to provide the imports array here, where we'll provide the Mongoose module for a feature and pass in our schema that we defined. So we know the name is going to be bookmark from the model.name, and the schema, of course, will be the bookmark schema that we've exported. So now that we have everything we need to actually persist a new bookmark, let's head into our bookmarks resolver and set this up so we can actually start creating new bookmarks. So in this resolver, we'll say that this is going to return of type bookmark. And now in our constructor, we'll of course need to inject the bookmarks service. And so our first mutation here we'll call use guards and provide it the GQL auth guard because we want to protect these routes and that make sure only authenticated users can create new bookmarks in our app. So this will be of type mutation from Nest.js GraphQL. Of course, this is going to return the bookmark model, and then we'll call async create bookmark. So now we need to specify the input arguments to create a new bookmark. So let's go ahead and create a new DTO folder for data transfer object, and then we'll create a new folder within called input, where we can keep all of our input classes. So our first one will be create bookmark input.dto, and this will be of course input type from Nest.js GraphQL. So we'll export a class called create bookmark input, and this is going to just take the name of the bookmark that we're creating. So we need to decorate this with the field property so that Nest.js GraphQL knows about it, and then we can apply some validation. So we want to make sure this value is not empty, and of course that it is a string that's passed in here. So now back in our resolver, we'll add the args decorator here. Specify it's going to be of type create bookmark data. So this will be called create bookmark data. This will be of type create bookmark input. We're also going to extract the current user off of the request object so that we can use that when we save the bookmark. And then finally, we're going to just return this .bookmark service.create bookmark, which doesn't exist yet, but for now we're going to pass the create bookmark data, and then we're going to pass the user.id into that call. So let's go ahead and define this in our bookmark service. We'll create a new async method called create bookmark, which will take the create bookmark data, which is of type create bookmark input, and then it'll take the user ID of type string here. So since we're about to create this bookmark, we need to get access to the repository that we've set up so that we can actually persist it. And now in this async create bookmark, we will set a new const called bookmark document and set it equal to await this.bookmarks repository.create. So we're going to provide all of the create bookmark data that was passed in. We'll set the links to an empty array, and then finally we'll provide the user ID. Now, just as we did with the user, we're going to actually have another private method in here called toModel, which will take the bookmark document, which is of type bookmark document, and it will simply return the same object, but the ID now will be a bookmark document .id.2hex string, and then we'll spread the rest of the bookmark document. So now in our last step in create bookmark, we'll just call this .toModel and pass the bookmark document like so. So now if we open up Postman and we have this new mutation here called create bookmark, we can pass in the create bookmark data with the name of test and specify we want to get all the properties back. Now make sure you've logged in before you send this request so that you can get a valid JSON Web Token cookie set. And then now if we execute this request, we can see that we get our create bookmark response back from the newly created bookmark. So I'm going to open up my terminal as we've done before in our UI and run ng generate module bookmarks. So this will create a new bookmarks folder and module for us, and then we can say we want to generate a bookmarks component as well. So now we have a bookmarks folder with the correct files. So we're also going to generate a new module called create bookmark, which will be responsible for actually creating the bookmark. And this bookmarks component will host the creation as well as the existing bookmarks we have. So now that we have the create bookmark module, let's finally create the component for create bookmark. So in our app module, let's go ahead now and make sure that we've actually imported the home module correctly. Because what I want to do now is inside of our home component, instead of this paragraph tag, I want to actually just output app bookmarks, which is the bookmarks component that was created for us here. So that on the home page, we'll automatically be displaying that bookmarks component. This also means in our home component, we need to go ahead and import the bookmarks module like so. This also means we'll have to open up our bookmarks module, and in the export section, we'll have to export the bookmarks component here so that we can use it in our home component. And also see we just specified the wrong path for our create bookmark generation. So make sure we actually move the create bookmark inside of the bookmarks directory. And within the bookmarks module itself, I want to go ahead and import the create bookmark module here because we're going to be using that shortly. So now inside of our bookmarks component.html, let's go ahead and create a new button, and we're going to give this an attribute of matte fob because this is going to be a floating action button. We're going to specify the color here should be primary. We're also going to give it a class of fob so we can apply some custom stylings, and then lastly we'll give it a click listener of on fob click. And inside of this button, we'll add a matte icon here of add. So now we're going to have to open our bookmarks module and make sure we add the necessary imports for material design. We'll import the matte button module, matte icon module, and then don't forget in our bookmarks component, we'll have to add the on fob click. And for now, we'll just leave it empty. So let's open up our bookmarks component CSS, and for the fob here, let's give it some styling. So I want position to be absolute. We'll give it a right property of 4rem and a bottom of 4rem. So now if we take a look at our app, we should see this nice floating action button at the bottom here. So when we click on this floating action button, I want a new dialog to appear where we can enter the name of our bookmark and actually have it created. So to do this, we're going to use the Angular material dialog component. And this is really easy to work with here. So we actually can inject the private read-only dialog of type matte dialog. And we import matte dialog from Angular material dialog. And we only need this matte dialog reference here. So now on fob click, we're going to call this .dialog.open. And then we can pass in the reference to the component we want to open. So in this case, it's going to be the create bookmark component. Now don't forget in our bookmarks module, we'll want to import the matte dialog module. So now back in our app, if we click on the plus, we should now have this nice dialog that pops up, letting us know that create bookmark component works as expected. So let's open up our create bookmark component.html and start building this out. We're going to start off with a container div here. We're going to give it an h2 of create bookmark. So this will be the title of our dialog. So this will be the title of our dialog. And then we're going to have a matte form. Okay, so we're going to have the matte form field to start off. We're going to give this an appearance attribute, and we're going to give it to outline here. Now within the form field, we'll have the matte label, and this will be called bookmark name. So we're going to get the name of the bookmark. So of course this will be an input of type text. We'll give it the mat input attribute, and then we'll specify the form control as we've done before. This should be equal to bookmark name, and we'll specify that it should be required as well. And finally, we'll provide the mat error field here, and we'll specify that it should only show, so ng if bookmark name is invalid. And if that's the case, we're going to call get bookmark name error. Lastly, we're going to provide the submit button here the user can use to submit this. We're going to give this a mat raised button. Specify the color should be primary. And then lastly, give it the click listener of create bookmark. And we'll provide some text of create here. So as you'd expect, we have to import the necessary material modules. So mat form field module, mat input module, mat button module, and then lastly the reactive forms module from Angular Forms. Now let's head into our component now. Firstly, we're going to set the bookmark name here equal to the new form control. We're going to give it a default value of nothing, and then provide the validators we'd expect. So validators dot required, and make sure we import validators here from Angular Forms. Next, we'll go ahead and add the get bookmark name error. So we'll just check to see if this dot bookmark name dot has error required. Then we'll go ahead and return you must enter a value. Otherwise, we'll go ahead and return an empty string. And finally, we'll go ahead and for now just have an empty method called create bookmark so that our onClick listener can call this correctly. We should now be able to open up our app, and then when we click this floating action button, we can see our ugly looking form here. So let's go ahead into our create bookmark.scss, and then we'll style that container we specified earlier. We'll say the display should be flex, and the flex direction is column. And then lastly, we'll set the H2 to align in the center so that our form will now look a little bit nicer. Once we click the plus button, we get this nice input field here with our validation as we'd expect. And so now we're ready to actually execute that create bookmark mutation. So as we've done before, we'll go ahead and actually write the GraphQL mutation that we want to generate code for. So we'll call create bookmark dot mutation dot GraphQL here, and we can simply call a new mutation here called create bookmark, which will take the create bookmark data, which will be of type create bookmark input. So now we'll call create bookmark, and we want to pull the ID, name, user ID, and we actually don't need to pull the links back for this mutation because we're going to make a separate resolver just for those links. So for now, we can just provide the create bookmark data, which will be of type create bookmark data that we specified up above. Make sure that your Apollo Angular code generator is still running in the background. We should be able to go back into our create bookmark component, and now we should be able to inject the create bookmark GQL. So we should be able to call create bookmark and have the create bookmark GQL show up for us. And now inside of create bookmark, as we've done before, we'll simply call this .create bookmark GQL .mutate. So then we'll pass in the create bookmark data, which will of course just take in the name, which we know is this .bookmark name .value. And after we create the bookmark, I want to subscribe to this call here, and then I want to close the dialog that is currently open, which is very easy to do with Angular material. We can simply actually inject the dialog ref here. So this is going to be of type mat dialog ref, and then we can pass in the current component in question, which is the create bookmark component. So we should have a dialog ref now that we can actually call in our subscribe. So we'll call this .dialogRef.close. Now, if we open up our app back up, let's go to the network tab here so we can observe what's happening. I'll create a new bookmark with a name called test, and I'll hit create. We can see our GraphQL mutation completed successfully over here, and we can see the preview data response with the name, user ID, and ID of the bookmark. So now that we have the ability to create bookmarks, let's go ahead and implement the functionality to display them here. Okay, so now we need to add the functionality in our backend to actually query our bookmarks. So let's go ahead and open up the bookmarks resolver. And in here, we're going to add a new query resolver. So we're going to decorate a new route here with use guards GQL auth guard, because this is going to be a protected route. Then we will use query from Nest.js GraphQL and say that we're going to return an array of bookmark models here. We're also going to give this a custom name of bookmarks, and that's because we're going to have a name of the function actually be get bookmarks to be a bit more descriptive. So instead of get bookmarks, we need to get access to the current user, and then we can simply call this bookmark service get bookmarks. And we'll pass in the user ID as we typically have done. So now let's open up our bookmark service, and we'll implement this new function here, async get bookmarks. So we'll get the user ID as type string. Now I want to reach out to our repository layer and get all of the bookmarks created by this user ID. So let's go ahead and open up our bookmarks repository, and let's add this functionality to our abstract repository. So we're going to go ahead and add a new function in here called find that takes the filter query, which will be a type filter query T document, and then we're simply just going to call this model.find. We'll pass in the filter query. We're going to set the projection to an empty object, and then we want to set lean to true so that we are not sending back a hydrated, more expensive mongoose document, but just the raw properties on the T document here. So now we're going to set a const, set it equal to bookmark documents, and it's going to be await this bookmarks repository find, and now we can just pass in the user ID to get all bookmarks by this user ID. And then our return value is going to be bookmark documents map. We'll get the bookmark, and we're simply going to return this .to model, passing in that bookmark. So we just transform all of these bookmarks into the actual model here. So now back in Postman, make sure we're authenticated by sending our auth request to set our JSON Web Token cookie, and then we'll send a bookmarks query just to get all the properties back. And so remember, this is going to return back all of the bookmarks associated with our current user ID. So here we can see the two bookmarks we've created so far. Now if I were to go back into our UI here and create another one, and then click on create, now if we go back to Postman and send this request, we can see that newly created bookmark. So let's go ahead and create this query in our UI. Under the bookmarks folder, we'll create a new bookmarks query.graphql, and we'll simply query bookmarks. So we're going to want to query bookmarks here, and then we're going to pull back the ID, name, user ID, and all of our links here. So now we can go back into our bookmarks component, and let's create a public variable called bookmarks $, to represent our observable that will hold our bookmark from generated types, and this will be an array of bookmarks. So now in ng on init, we make sure first that we're going to want to inject the bookmarks GQL. There's a type bookmarks GQL here, and then we're going to set this .bookmarks equal to this .bookmarks GQL .watch, and then we're going to call value changes, so we actually listen to changes in this value, whether it be from a direct call or a change in cache. And then we're going to pipe a map operator on it from RxJS, where we get the result back, and then we're going to return result.data.bookmarks. So now we actually have bookmarks coming in. So now let's open up our bookmarks.component.html, and above our fob action button here, we're going to go ahead and add an unordered list and give it a class of bookmarks here. Then we can go ahead and create our first list item and give it a class of bookmark. So we're going to open this up, and we're actually going to specify an ng4 here because we want to iterate over to each of our bookmarks. So we're going to say let bookmark of bookmarks, and we're actually pulling this observable value in our component here, and we're able to pipe it using the async pipe here, which will automatically subscribe to this observable and show us the most recent results. So to display this data, we're going to use a mat card. and we're going to give it a click listener. For now, we'll just call on bookmark click, and we'll pass in, and we're going to pass in the bookmark.id so that we know which bookmark we've clicked on. And inside of this mat card, I'm just going to include an h3 here, and we're going to output the bookmark.name. So make sure in our bookmarks module that we go ahead and import the mat card module. And this is imported up here from Angular material card. Finally, let's go back to our bookmarks component. And for now, we're going to specify the on bookmark click function, which we know gets the bookmark ID here of type string, and we can leave it empty for now. So lastly, let's open up our bookmarks component.scss and add some more styling here to make things look a bit nicer. First, we'll style each individual bookmark. We'll give each one a margin bottom of 1 rem and specify a fixed width of 13 rem. Then we'll style the entire bookmarks class here. We'll give it a display of flex. We'll say flex direction is row. We'll do a gap of 1 rem here. I'm going to say flex wrap to wrap. Give everything a padding of 0 here, and then specify a margin of 1 rem. Finally, within the bookmarks class here, we're also going to style an h3 and give it a text decoration of underline. And lastly, we'll give each list item a cursor of pointer so that it looks like it's clickable. Finally, let's go into our root SCSS file. So if you open your source up and open up app folder, finally in our styles.scss, I'm going to go ahead and add a global style to the stable list style type on our list items altogether. So now if we go back to our UI, we should see those 3 newly created bookmarks in a grid here. Each one of these is its own card that we can soon navigate to. However, we have one problem right now. If we were to go ahead and create a new bookmark here and click create, we notice we don't actually see the newly created bookmark unless we were to actually refresh the page, and then we see it. So let's go ahead and see how we can invalidate this cache and make it actually repopulate this list when we add a new bookmark. So let's go ahead and open up our source bookmarks, and in create bookmark in our component here, we have our create bookmark function. In addition to the actual data for this mutate call, it takes an options object here where we can actually specify queries that we want to re-execute after we create this mutation. So in this case, we know we want to re-execute the query to get all of the bookmark. So we can specify an object here and specify query and set it equal to bookmarks document from generated type, which if we go ahead and take a look is just the GQL, the graph query language for all of the bookmarks here. So now if we were to go back to the UI and create a new bookmark and create this one, we can see that our cache is invalidated and we immediately see the new bookmark in the grid here. So now we need to add the functionality to be able to click on one of these bookmarks and actually go to a unique page for each one and see a list of URLs or links for each bookmark. So to do this, I'm going to open up the terminal in the UI and run ng generate module, and it's going to be called bookmarks bookmark. So we're going to generate a module within the bookmarks folder called bookmark module, and then we're going to go ahead and generate a component for this as well. So now we have a bookmark component and module. Next, let's go into our app routing module and add a new route for an individual bookmark. I'll create a new object up here and we'll give it a path. So the path will be bookmarks, and then it'll be the ID of the bookmark. For the component, it's of course going to be the bookmark component, and we're going to apply that same auth guard we've had so that only authenticated users can visit a bookmark. Lastly, let's go into our app.module and actually import the bookmark module here. So now that we've correctly imported this, we can go into our bookmarks component and actually finish out this on bookmark click function. So as you've probably guessed, we're going to need access to the router here. So let's inject it. This is going to be a type router from Angular router. And then we're going to call this .router.navigate. And we're going to pass in an array here as we typically do and give it a slash bookmarks. And then we can go ahead and provide the bookmark ID as the second argument to this array. Now back in our UI, if we click on one of these bookmarks, we can see we're navigated to the correct URL, and we have the bookmark works component text here. So now we need the functionality to actually query a single bookmark. So let's open up our bookmarks resolver and let's create a new route here. Of course, as always, we'll have the GQL auth guard protecting this route. And then we'll have a new query, which will of course return a single bookmark now. We'll also go ahead and give this a name of bookmark. So this will be an async get bookmark function. And now we need to specify the args for this get bookmark call. So in our DTO folder, let's create a new directory called args. And let's create the get bookmark args.dto. So this is going to be an args type from Nest.js GraphQL, and we'll export the class get bookmark args. This will be a field here, and it's going to be the ID of the bookmark that we want to query. So we'll go ahead and apply some validations, say it's not empty, and of course this will have to be a valid string. So now we can provide a parameter decorator, the args decorator, and we'll say get bookmark args of type get bookmark args that we just created. We'll also go ahead and get the current user, because we only want to allow the user who owns the bookmark to be able to query it. So we'll call this.bookmarkService.get singular bookmark, which we'll implement. We'll pass in the get bookmark args and the user.id. So let's open up the bookmark service, and underneath get bookmarks, we'll create a new async get bookmark function here that takes the get bookmark args and the user ID of type string. So this is simply going to create a new bookmark document, and we'll call await this.bookmarks repository find one. And so now we're going to go ahead and spread all of these get bookmark args, and then we'll say the user ID has to match the one on the request object. Finally, we'll call this.toModel and pass the bookmark document so we return it properly. So now back in our UI, let's go into our bookmark folder, and as we've done before, we'll create a new bookmark query.graphql. So this will be a query for a single bookmark, which will of course take the ID of the bookmark, which is of type string, and this is going to be the bookmark query. So we have the ID here of type $_ND, and we're going to want to pull back the ID, name, user ID, and the links on this bookmark. So now back in the bookmark component, we're going to make the bookmark itself the public member here from generated types. Back in our constructor, we're going to go ahead and inject the current route. So this is going to be of type activated route from Angular router. And then we're going to get the newly created bookmark GQL of type bookmark GQL. So now in an ng on init, we want to actually listen for the changes in the route parameters, which is containing the ID of the current bookmark. So we're going to call this.route.params, and we're going to pipe on it. And inside of this, we're going to call switch map, which essentially will allow us to switch to a new set of code each time this observable in this pipe here changes. So each time the route actually changes, we want to start doing something different. And in this case, we want to call our bookmark GQL. So we'll get access to the params in here, and then we're going to return this.bookmarkGQL.watch, and then we're going to pass in the ID property here. So we're going to pass in from the params the ID parameter. And then we're going to return the value changes property here, which actually returns the observable. Finally, we're going to subscribe to the end result here, which we'll call results. And then we'll be able to set this.bookmark is equal to result.data.bookmark. So now in our bookmark.component.html, let's go ahead and create a new ng container that will have an ng if, and we'll say we only want to show this content if we actually currently have a defined bookmark. If we do, we're going to go ahead and use the matte toolbar here and specify the color should be of type primary. Then we're going to specify the name of the bookmark. So I'll pull the name off the bookmark here. I'm going to create a new span and give it a class name of spacer to give it some spacing between the name and this new icon we're going to add to be able to add links to our current bookmark. So let's create that button right now. Give it a matte icon button attribute and a click listener here of on add. Then we'll use the matte icon and use that add icon we've used before. So go into your bookmark module, and now in our import section, we'll have to import the router module, matte toolbar module, matte icon module, mat button module. And from there, go into our bookmark.component and let's create this onAdd function for now and just leave it empty. Finally, let's create that spacer class in our bookmark component.scss, and we'll style it with a flex of 1:1 auto to give it the spacing that we would like. So now back in our UI, after we log in and click on a new bookmark, we should see this nice toolbar here with the name of the bookmark as well as an add button. So next we're going to go ahead and create a component that will allow us to actually add a new URL to our bookmark folder. So let's create a new terminal here in our UI, and let's run ng generate module, and this will be in bookmarks bookmark add link. So this will generate the module for us, and then we'll do the same thing to generate a component. So now that we have this add link component here, let's open up our bookmark component so that we can actually use it. So we're going to use this add link component as the host for our dialog, like we've done before when creating a new bookmark. So in our bookmark component, we're going to need to go ahead and get a reference to the dialog. So let's get a reference to the mat dialog here in the constructor, and then an onAdd function here. We're then going to call this .dialog.open, and then we're going to put a reference to the add link component in there. And then next we can also specify some data to pass to the dialog component. So in this case, we're going to want to pass a data object, and then we're going to want to pass in the actual bookmark that we are adding a link to. So in this case, we'll just pass this .bookmark. So now back in our browser, when we click on the plus button, we should see the add link works text here in our little dialog. To actually build out our add link component a bit more, let's actually open up the create bookmark component HTML and actually just copy over this existing dialog component HTML and add it to the add link component. Now we're just going to want to change a few things here. Instead of create bookmark, we'll replace this text with add link. We'll change this mat label here to be link instead of bookmark name. And the form control, we'll give it a name of link here. And the ng if should be link.invalid. And then the function name we'll call getLinkError. Finally, let's go down into our click listener and change the click listener to add link. And we'll change the button text to add instead of create. So now let's head into our add link component and start building this out. First, we'll add our link form control here from Angular Forms. We'll give it a empty string as the starting value, and we'll just add a required validators. And make sure we import validators here from Angular Forms. Next, let's go ahead and implement these functions. Get link error to start. So like we've done in the past, we'll check to see if this .link has error and has error required. Well, in that case, we'll return a string saying you must enter a value. Otherwise, we'll go ahead and just return an empty string because there is no error. And lastly, for now, we haven't implemented our ability to add a link on the back end. So for now, we'll just provide it as an empty method. And now let's finally go into our add link component CSS and style that container where our form is and give it a display of flex and a flex direction of column. And don't forget, we now have to go to our add link module and add our imports. So we'll have the mat form field module, the mat input module, the mat button module, and the reactive forms module from Angular Forms. Finally, let's open up our bookmark module and import the add link module now we're actually using it. So now if we go back to our UI and open our link dialog, we should get that nice input text where we can add a link. So now let's go ahead and finally add our last resolver route for our bookmarks, the ability to actually update a bookmark. So underneath create bookmark, we'll follow our standard pattern. We'll decorate it with use guards and add the GQL auth guard. I'm going to say this is a mutation that of course will just return a bookmark in the end, but it will be async update bookmark. And so now we need to add some args, or some input rather, to be able to update a bookmark. So in our DTO input, we're going to create a new file called update bookmark input.dto.ts. This is going to be an input type as always, and we'll export the class update bookmark input. So we're going to have two fields. First one will be the ID of the bookmark that we're updating, and then the other one will be an array of strings, in this case the lengths, that we want to actually update. So since we have an array of strings here, we need to specify this explicitly in our field decorator as an array of strings. And now we can add some validation. So we want to say this is an array, and additionally we can also say that this should be an array of URLs. So we'll say undefined for our first arg here, and then we're going to specify each to true to specify that each value in this array should be a URL. Up here for our ID, we'll also add is not empty and say that it should be a string. So now back in our bookmarks resolver, we can decorate this parameter with the args decorator and say update bookmark data. So we'll call this update bookmark data of type update bookmark input. And of course we'll get the current user, because we only want to allow a user who owns a bookmark to update it. And then we'll call this .bookmarkservice.update bookmark. We'll pass in the update bookmark data and the user.id. So now let's go ahead and enter into our bookmarks service and implement this async update bookmark method, which we know takes the update bookmark data of type update bookmark input, and we get the user ID, which is a string. So now we need to reach out to our repository and find one and update. So let's go ahead and actually implement that functionality in our abstract repository. So underneath find one in our abstract repository, we're going to add a new async find one and update. So of course we're still going to take in a filter query here. So there'll be a filter query of type tDocument to actually get the document we want to update. And then we're going to have the update commands, which will be the update query here of type tDocument. So now we're going to actually find one and update on the model. So we're going to get a reference to the document here and call await this.model.find one and update. So we'll pass in that filter query, the update command, and then an options object. So as we've done before, we're going to set this lean to true so that we get back just the plain old document with no extra added properties on it. And then we're going to set this property new to true, which means that when we update this document, we want to pass back the newly updated one and not the old document. So let's do some error handling here. We'll quickly check to see if no document was returned. Then we know that the document was not found by filter query. So we can warn in our logger saying document not found with filter query, and then we can actually pass in the filter query. We'll also throw a new not found exception and say document not found. So if we have found the document, that means the update was successful, and we'll just simply return it back to the caller now. So back in our bookmarks service now, we can actually make use of this method here. We'll declare a const bookmark document and set it equal to await this.bookmark repository.find one and update. We'll now pass in our filter query. So we know this should be an ID property from update bookmark data.id, and then we're going to pass in that user ID. So we only get bookmarks from that user ID. And then lastly, we're going to pass in the update bookmark data to pass in all our updates to this document. Lastly, we're just going to return this.toModel and pass in the bookmark document. So now if we wanted to test this out, we'll take the ID here from one of our bookmarks in our UI, and then we'll go into Postman, and you can see I have this mutation here I've created called update bookmark. I pass in the ID and the new links that I want. So of course, make sure we're first authenticated with our JSON Web Token cookie through the auth route, and then we'll fire off this request. And you can see here our validation is working properly. We're getting an input error saying that our link needs to be a valid URL. So we'll say http www.google.com. Let's see if this one works. So now if we send it off, we can see our updated bookmark was sent back successfully. So let's head back to our UI now, open up our bookmark folder, and in our add link folder, we're going to add a new mutation. So this will be the update bookmark.mutation bookmarks.graphql here. And we're going to want to execute a mutation called update bookmark, which will of course take the update bookmark data, which will be of type update bookmark input here. So this will be update bookmark, and we'll pass in the update bookmark data, which will be of type update bookmark data that we just specified. And then we're going to want to get back the ID here, the name, user ID, and links. So now in our add link component, let's firstly go ahead and inject the bookmark, the update bookmark GQL, which should be automatically generated for us in the background if our npm generate command is still running. So we have our update bookmark GQL, and now we actually also need access to that dialog data that was passed in from the bookmark component, which contained the bookmark in question that we're actually updating. So to get access to this data, we can use the inject decorator from Angular core and then pass in mat dialog data. And this is imported from Angular material dialog. So now this is decorating this read-only data property, and we can give it a type which we know has a bookmark of type bookmark. So now we have access to this bookmark that we're actually updating. Let's also go ahead and get a handle to the dialog ref itself so that we can close the dialog after we correctly update the bookmark. So we'll pass in the current component, add link component. So now in add link, we're going to go ahead and call this .update bookmark GQL .mutate. We're of course going to need to pass in the update bookmark data. So in this case, it's going to be the ID that we need to pass in. So we'll pass in this data.bookmark.id, and then the links that we want to update for the bookmark. So what we're going to do is we're going to copy all of the existing links on the bookmark, and then we're going to add the new link that we've added from our form using this .link.value. Now, as we've done before, after we update this bookmark, we want to invalidate its cache so that we see the link in the UI after we update. So to do this, we're going to add this new options object where we can specify the refetch queries parameter. So we're going to set this equal to an array, and then we'll open up the object inside of here. And now we can specify the query that we want to refetch. So in this case, it should be a single bookmark document that we want to update. But now we also need to provide it variables, because if we look at this query for the bookmark document, we can see it expects the ID of the bookmark. So to fix this, we can actually provide another property here called variables, where we essentially inject this ID. And we of course know this comes from this .data.bookmark ID. So now we're only going to refresh this one bookmark document. Lastly, don't forget we still need to subscribe to this call. And at this point, once the call succeeded, then we want to actually close the dialog ref. We'll call this .dialogRef.close. So now back in our UI, I'm going to open up the network tab here. And if we go ahead and add a valid link, so google.com, and click add, we can see that we successfully update the bookmark with the links coming back here. But then we can see this other request going to get the most recent bookmark data because we've invalidated it. So the final step in our app is to be able to actually query for all the links in the bookmark so we can display them here and actually click through on them and make use of our bookmark manager. So to do this, I'm actually going to create a new terminal in our backend, and I'm going to run Nest generate module, and I'm going to generate a new module called links. So this will go ahead and create a new links folder. So now we have a module for links. I'm going to generate a resolver as well. And lastly, we'll generate a service for links. Now we're also going to make use of a third-party package called link preview.js, which will allow us to supply a link and get metadata about it, like thumbnails, description text, site titles, and so on, which should be useful in our app. So let's go ahead and npm install link preview.js. And now we can go ahead and specify our model for what a particular link will return from our backend. So we're going to specify the object type here and export the link class. So this link preview.js gives us a lot of information based off a link, but we're only specified with some number of fields. So let's get back the title of the web page where the link originates from, and then we'll get back the actual name of the website itself. So we'll get a read-only site name here. We're also going to want to return the URL itself. So we're going to label this as a URL string. And then lastly, we're going to return an array of strings here, which are going to represent an array of images that we return based off of this URL. So now we can go into our links resolver and specify that this will return a link model here. And we can go ahead and start building this out. First, we'll inject our link service, which we will be using shortly. And then we can specify our only resolver route in this resolver, which will be a query. So import this from Nest.js, GraphQL, and not common, which we know will return an array of links here. So we're going to give this a name, as we've done before, of links, and we'll call it async get links, where we now have a set of args, and we'll say get links args. So now we're going to have to define these args. So let's go ahead and create a new DTO folder here, and inside of this one we'll specify our args, and we'll create our get links args.dto.ts. So this should be decorated with our args type decorator. We'll export a class called get links args, and this is going to just have one field, which is an array of strings. And you probably guessed it, but it's going to be an array of our URLs. So we're going to decorate this as we've done before with our isURL validator, where we specify undefined as the first parameter here, and then we'll say each set to true so that this validation occurs for each member of this string array. So now we can specify the type for this get links args. It's going to be get links args, and now we can simply return this link service get links and pass in the get links args. We're also going to go ahead and decorate this with our use guards and pass in the GQL auth guard so that this is a protected route. So let's go into our link service and implement this simple function here called async get links. So we'll have the get links args, type get links args, and now we want to essentially iterate over all of the URLs here and return a link preview for each one. So this is going to be an asynchronous task, and to make this as efficient as possible, we're going to use promise.all so that we can execute this asynchronous work in parallel for each URL and make it as fast as possible. So we're going to return promise.all here, and now we're going to pass in our getlinksargs.urls.map, and so this is going to return an array of promises. So we want to make this callback an async function here that gets the URL as a parameter, and we're simply going to return get link preview, where we pass in the URL. Now make sure we import get link preview up top from link preview.js. So now back in Postman, if I were to execute this new query called links, I'm going to pass in an array of URLs here. So now I'm actually just going to copy in the npm package link for link preview.js, get back the title, site name, and images, execute this, and you can see, very cool, we get back this metadata from just this link. So the last step for our app is now in our UI. We'll go back into our bookmark component, and in our bookmark folder, we're going to add a new query. You probably guessed at this point, same pattern. We're going to add a links.query.graphql, and we'll specify the query for links here. So this is going to be a URL parameter, which is going to be an array of strings, which each one is required, and the whole array is required. So we'll specify that. And we'll have the links query here. We'll pass in the $sign URLs. Then we're going to extract the site name, the title here, images, and the URL. So now we can go back into our bookmark component, and we can inject the automatically generated links GQL of type links GQL. So now that we have access to the links GQL, I'm going to go up here and we're going to add a new member. So the links will be an array of links. And I'm also going to add an isLoading property instead of to true to begin with, because we're going to go ahead and add a loading indicator to this page as well to make things a little bit nicer. And now we're ready to refactor our ng on init method to include our query to get the links. So now we're going to go ahead and add another switch map function here because we need to add another observable to this stream. So this switch map will get access to the response of calling this.bookmark.gql.watch. So essentially what we're going to do is we're going to pull this logic from the subscribe block and put it in the switch map block here. So we'll change this to result, and now we're setting the bookmark correctly. So now we're going to return this .links.gql.watch, and we'll pass in the variables. So in this case, it's the URLs, which will come from the result.data.bookmark.links. And of course, this will be the value changes property that we return. So now in our final subscribe block here, we'll get the end result, which at this point we can set is loading to result.loading. And we'll also say this.links is equal to result.data.links because we now have the links. And the reason why we use another switch map here is because if at any point in time the bookmark GQL watch function result changes, we want it to immediately call this again and cancel any existing calls, which is what switch map will allow us to do. So now let's open up our bookmark component HTML and start building this out a bit more. Firstly, we're going to add a new div here and give it an ngIf. So this will be where our loading indicator will be. We'll say is loading, else we're going to show links. So inside of this, we're going to have a mat spinner, which is a nice loading indicator. And we're going to give it a class of spinner so we can add some custom styles. So if the spinner is not showing, we'll have an ng template here, and of course give it a hash of show links. So inside this ng template, I'm going to have a new unordered list, and I'm going to give this a class of links, and we're going to have a list item here. We're going to give this list item a class of link, and as you probably guessed, we're going to have an ng for now, where we say let link of links, which is pulling from our links array in our component. And for each list item here, I want to use a mat card and add a click listener. So I'll add a click listener and say on link click. I'll pass in the URL of the link. And inside of the mat card, I'm going to have a mat card title group, which just adds some special styling for titles. So inside of here, we'll add a mat card title, and then we'll specify the link.title, the link.title here, and we'll do the same thing for the site name, but this time we'll do the mat card subtitle, and we will put in the link.site name for the subtitle. Lastly, we'll include an image here. So for the image source, we're going to use the link.images and use the first element in the images array that we find. Now importantly, I'm also going to apply the mat card medium image attribute to the image here to make sure that the image doesn't get too big. So now let's open up our bookmark module and make sure that we have all of our imports done correctly. We'll have to import the mat card module as well as the mat progress spinner module. And you can import the mat progress spinner module from Angular material progress spinner. So let's open up our bookmark component and let's add that on link click method that we specified, where we know we get back the URL, which is a type string. Then we can simply call window.open, pass in the URL, and specify this should be blank because we want to open it in a new window. Lastly, let's open up our bookmark component CSS and add some more styling here. So first, for our links container, I'm going to give everything a padding left of 0, get rid of some default styling. For an individual link, I'm going to give it a margin bottom of 0.25 rem. And then the spinner itself, we're going to give it a margin of 8 rem and then auto to center it. Lastly, for each list item, we're going to give it a cursor of pointer so it looks clickable. So now back in our UI, I'll create a final bookmark here. So once we create this, I'll go in and I'll add a random link from a news article I found online. And after we add it, we can see our newly created link here with the site title, the site name, and a nice little image here. And if we were to click on it, we get brought straight to the article. And let's go ahead and just try this with a random other article to see multiple links here. So now we can see our links pop up, and if we quickly refresh the bookmark, you can briefly see our loading indicator in the background before our data is fetched. And this is obviously persisted between application refreshes. So now we've built out a fully functioning bookmark manager using Angular, Apollo, and a GraphQL backend. I hope you've learned a lot about this Angular Apollo code generation. I think it's a really cool tool that allows us to build UIs very rapidly. So that's it for this one, and I'll see you in the next video.